Good morning, everyone. Welcome to this 126th edition of the Zak World of Façades conference series. My name is Ahmed. I'm part of the organizing team here. I'd quickly like to introduce the event to you before we get into the proceedings. So we've been organizing the Zak World of Façades conference series since 2012. This is edition number 126. So we've had 125 great editions across the globe. We're present in 40 countries, so this is our 9th or 10th North American edition, if I'm not mistaken. So right from New Zealand up until Canada, events are spread across. Every country is different. Every region, the way facades are designed, engineered, constructed, installed are very different. So it's been a great challenge for us in incorporating the local norms, design strategies, customs into our events, and also take inspiration from one region to another region. So it's been a great journey in the last 10 years. We're slowly increasing our footprint in North America. This is our first edition in DC, but of course we've done 9-10 editions across the US, Canada, and also in Mexico. This is what we're doing for this year. So they're all spread across the events. We've finished half of them, halfway mark to the year. So this is what the 2023 lineup looks like. This is our event website. I'd like to thank our event partners, starting off with Boston Valley Terracotta. So they are a leading manufacturer out of Boston, doing terracotta panels for cladding, for roof and other applications. Cosentino is a Spanish company. Their facade material is called Dizon. It's a nice synthetic stone, non-combustible, recyclable product. Guardian Glass needs no introduction, one of the leading high-performance coated glass manufacturers. Ahmed is a cladding supplier of various metals. ISD is a software solution provider for windows and facades. And cladding, of course. Curare is the parent company of the laminated glass interlayers, Throsifol and Sentry Glass. Sherwin-Williams, this is the coil coating division, again a big coating supplier of liquid coatings. Shildan is another leading supplier of terracotta and other cladding materials for facades. And then, of course, our last partner for today is Synergy, one of the leading manufacturers of stairs, balustrades, and other stuff. All our partners have our booths outside, so request you to please interact with them during the networking breaks. Our next event is 3 weeks from now in Hyderabad, back in India. We've got then Hong Kong, Shanghai, and then the last two events, of course we've got events in between, but the last two events in North America is New York, and we've got Montreal. Okay, that slide is missing. So Montreal is on the 19th of October. So these are our two pending events in North America, New York and Montreal, back-to-back weeks. And yes, so this is a small, intimate gathering. We've got some great presenters today presenting. We will go straight with the presentations after this, and just a few rules. So we will not be taking any questions. So any questions you can ask the speakers at the break. We've recorded today's event, so if you miss any lecture, you'll get a YouTube link a week from now, and you can watch the recording of all the presentations which we have permission to share with you. And then those who have the red delegate badge, you will have a USB stick on your lanyard. So the USB stick has the brochures of all our 9 participating sponsors today. So that's it from me. Before we get into the program, I'd like to call upon today's event host for the morning session, Angel Dizon. He's a senior executive with the US federal government. So he's going to be hosting today's AM session, and he's going to take this from here. I'm not going to introduce anyone, nor is he going to introduce anyone. Our bios are going to come up on screen. So we get straight into the program, and Angel, over to you. Thank you.
Thank you, Ahmed. He's moving pretty quickly there because we're behind schedule. We're way behind schedule. So part of my responsibility is to make sure that we get back on track. So that's me. My name is Angel, and it's pretty cryptic up there, but what you should know about me is that I used to work for the State Department doing embassies and consulates all around the world, and now I work for GSA as the Regional Commissioner for the Great Lakes region. And so I am your client. The work that you do is very, very important to me. And by the way, I don't give you enough time to do it, and I don't give you enough money, but I'm expecting a lot, right? So what I've learned out of all this experience is that the facades and the buildings that you provide need to provide me three things. They need to be functional, right? There's still a building envelope, but they also need to be performative. And in this day and age, I'm asking you to do a lot in that regard. And sometimes that performance is related to security. For some of these folks that have done some of the State Department work, it's a lot of stuff happening in that one little plane. And then the last thing is that it needs to be representative of your client, right? And for me, I represent the US government, so the work that we do has to represent us as American citizens and us as the US government. That's about all the intro I'm going to give because everybody ate up my time out there having breakfast. So I'm going to turn it over to Rebecca and Chris and let them kick off the day with what they're going to be. It's about Amazon, right?
Yes.
And I'm not sure if my notes are right, but I believe they're going to be handing out Prime memberships. Is that correct? I might be wrong on that, but anyway, Rebecca and Chris. Thanks. Just so that we can keep the schedule going, I'm going to turn it over to Paul Totten from WSP, who is now getting his mic fixed. Do I think I'm good? You're good. Okay, come on. Look.
Good morning. So very good presentation on looking at new construction. I'm going to take you through the elements of looking at reclads. Plugins, where like we did with Seldorf and Core here, where we took a historic set of buildings and plugged other buildings around them, do the expansion joints, all the current wall connections, the roof tie-ins. Elevation is very tricky. Next slide. Oh, I keep on forgetting that I got that. All right, we can go. So I'm going to take you through existing building challenges, thinking about the structure, thinking about concrete strength, thinking about framing, foundations, so you can put on a building. We're going to add floors to a building. We're adding loading. We're adding displacement. We're running risk of water problems on adjacent structures. We will look at that. Talk about structural considerations. Well, it's always going to align with the floor line. It's going to be for that element that is not quite where you need it. We're talking about the layout of the new system. Patience in putting stuff up, and I think that's going to be absolutely critical. Let's look in the perception. Where's the public perception of the change? So we look at some of the projects we've worked on. The African American Museum, we were brought in by the Smithsonian. The thought process for the dynamic coating on the museum. How to take a coating product and make it in a different way, give it absolutely no glare, and have it do something that the birds are tricked want to roost on the building. And we did that by taking Durnar actually in this case, and actually modulating the color thought process. He then took to the final colors that he was like increasing clear coat at the top, so the light would come through like the prism, create that reflection at grade. Nope. Looking at it, but we may think about the coating only works outside. You cannot use this coating inside. In fact, Dave, I'm probably going to end up losing the mic. That's fine. So anyways, if we look at the actual process, it was taking it to a different place, right? Taking it to a different location. I'm good. I'm loud enough that you don't need to mic me. Anybody knows me knows that. The International Spy Museum, which is close by, want to do something fun at lunch hour. The back of the building, one of the most tricky metal panel layouts we ever had to look at, is an actual spy message in code. So the spacing of the ribs of the panel create the spy message. So when we looked at the shop drawing, like, I don't think that's what they meant. You need to reshuffle. So that was absolutely critical. I'll tell you what it says. So today I'm going to talk about a lot of headquarters. A lot of headquarters is a very interesting building. It's also within walking distance. Nice brutalist building, kind of ugly. And we took this nice elegant building with our client studios, added a few floors, and then had to look at different layout of the glazing to align with where we need to have essentially vision light. Also a top performer, right? We want to look at HVAC layout in the new space, but there's so many problems with going through these that you have to look at. So current floor height. How much space do you have for your infrastructure, your IT cable runs, your HVAC, your lighting? What are your floor to ceiling heights at the floors that you're working in? What type of material is actually there? So this is a building with heavy precast and ribbon windows, and we're going to cut those out. We have current layout of anchorage. How do you align your new anchorage to avoid hitting the old anchorage location? If you chip them out, it's going to be a weakened location. Or if you retain them, are going to be a conflict to actually laying out your vertical models. Looking at the actual elements that are there, doing a survey at the very beginning. What are the restrictions for height? And then what are you restoring? What's going to be essentially built back up? And what are you renewing, replacing with new systems? All this has to be planned at the very beginning of the job, step by step between the structural engineer, the enclosure specialist, the architect, the interior designer. You're bringing a much bigger team, and as early as you can bring on the contractor. On this project, we were actually retained by Gilbane, our contractor client, and somebody else we've done a lot of work with on these complex reclads. So first thing, review the concrete strength. So you have a set of drawings. Concrete strength says 5,000. Go take cores. We got 2,500, 3,000. We may have got to 4,000 in some of the cores. We don't have the strength on the drawings. So it meant that our anchor spacing had to increase to be able to take all the wind loading and other capacity, which meant the vertical layout of our mullions wouldn't be so straightforward. And actually, I'll just go back. So you want to understand the location of those embeds and the anchor, the locations of columns. Where do you think you're going to have a peculiar vision light? You're actually going to end up with a column construction. So mapping that out, absolutely critical. So we look at the renewal systems. Here we have at the very top, on this one, the out of the steel. at the very top of the building. We're extending this 2 floors. We were able to get more floor-to-ceiling height at the top 2 floors. A lot better vision, wonderful view of the Capitol from this location. And able to add green roofs on the top of the building. If you remember during construction, this building did make the news. We had a roof fire, right? Hot applied roof fire. Burnt part of the curtain wall. We had to go back and reassess anchors. So also care in construction, right? Not much we could do. We made a 3-alarm fire. That was pretty awesome. But then we can start seeing some of the elements that we're seeing of the standoffs that were used to change our receiver for the horizontal. So we can stay with the vertical layout we wanted by not relying on the building that was there. We changed the location to essentially get the elegance layout that the architect wanted. This is absolutely critical when we're doing this type of building. When we're doing a reclad, you're going to run into too many issues trying to align with what's there most of the time, not all the time. And so switching up how you're anchoring is absolutely important. And if you look at that, then you have to look at the sequence of components going in. How you make it watertight, how you're dealing with the expansion of building movement, system movement, how you do corners. So you get good alignment. There's nothing worse than getting to a corner, the whole thing's kicked open. 1, it's going to leak. 2, you're going to get air leakage. 3, probably bugs, right? So you're going to have all those issues in the process of looking at that. I think it's critical then to go through the sealing process of where you're putting in critical seals right on the system, making sure that that's being done in sequence with the install. So this is just dealing with a receiver, essentially a giant sill flashing, if you want to break it down to the most simplest way of thinking about it. And then as you're adding height, you have to understand you're going to start cladding while still working with a crane to erect steel at the top of the building. On this site, as many sites on a reclad, you don't have much space to store materials. You have very little room. You either have a garage below grade, or you have floor to floor where you're going to be storing your materials. So the process of getting materials into the building, the sequencing of schedule tied to that, and then the sequence of what you're putting up to not create issues, putting up hot applied and having it drip all over your curtain, probably not the best thing. So working through that sequencing is going to be very critical. We had a lot of meetings early on in the project in the trades to discuss critical sequencing. How are we going to get the building up with efficiency while still allowing it to be done properly and not have to go back and do too much rework? So the other thing is having good quality control throughout the process. You need to have your enclosure specialist coming out, your architect coming out, and verifying as you're moving beyond mock-up phase, the initial install through process, you're getting exactly what you need, because going back and redoing things is going to A, delay schedule, B, may cause damage in the process, and C, may be difficult because you have limited storage space to take that stuff off, rework it, and put it back up. So this is all programmed in. The floor plate on this is not very wide, so it creates limited space for actual storage. And so we look at our initial setting of the system. We want to go and look at alignment. There's a corner. You can see some of the gas fittings out. It's a good time to actually work through what's being missed. When in the process of putting this up, we need to go back and look at with a little bit closer eye to really understand that alignment. Are we having elements that are needed for water draining or for keeping air out that we need to go back and rework on this first element? And as you can see, we still have work going on above the system. How are we protecting it so we don't get broken glass while working in steel? So all stuff that you have to work through in sequence. Those construction meetings, you have an AOC meeting, owner, architect, contractor meeting. We went AOCC, owner, architect, contractor, consultant meeting, so that you can have the consultant in those key parts to really talk through that. And as we're starting to set the system, we can have our staging on the inside. Our wonderful team from TSI did an excellent job of laying the system out, really understanding the runs they were going to run. We see critical sealing work going in. This gets missed, right? People stage the floor, and they want to just go and bang the system out, and they forget there's critical seals for water tightness within the receiver, within the corners. And when you get the first test, you're going to major rain, which, by the way, is a better test. You get a major rain on a building, it's supposed to be dried in, you will find every leak within hours of that rainstorm. The nice thing with climate change, there's also all sorts of not nice stuff. You want to talk with me on the break on that, on climate change? Is that we're going to see more short duration volume storms in DC, which has high risk for roof overflow, increase your plumbing number of drains, go twice what the code requires. Especially on smaller roofs. You're going to have a smaller roof that will overtop and flood very, very quickly. But getting this critical sealant work, which is absolutely important for a curtain wall, has to be done. So your checklist, right? And then your installers, you get them up and running on that early on in the project. You want to meet with them and go through anything you're finding so that they're staying on top of it. So we're getting our critical sealant work in, and then we're getting our hoisting. So this is going to swing outside and then be reset on the inside in the process. This takes patience. Right? If you're swinging these things too quickly, you could start racking them in a way that's not healthy for the pre-made unitized system. We want to make sure that we're taking the time to lay it up, put it into place, set it, and then get on to the next one. So when we look at the schedule, we'd always want to see is how aggressive is the installer planning to do each floor. I guarantee if they're going overly aggressive, you're going to run into all sorts of fun problems. So we have that coming now out and then being set down. And what we end up is a very renewed aesthetic. Once we're done, we're getting the spandrel kind of done off the bottom of the system, off the standoff, so we can plug those in kind of after the fact. Again, all unitized with some critical sealing work. We have enough space to do that on site as they were finishing the erecting for the top critical seal, which you can see sort of at the, I'll go back. Bottom here, where the spandrel height's at. It allowed us a lot of critical checking of the seal between the two units, which was also pretty key for this project. And then what we have is elegance in the completion of this. Again, on one side we had a very narrow floor plate, so you're reusing the existing historic portion of the building, right? Essentially this thing down here will not change that much, just reclad. Applying it into a variety of cladding materials, including metal panel and some other really wonderful systems. Getting some of the ginger red on the facade, which yes, helps with the painting, but was mostly done for aesthetic on this one. All require that thought process from the very beginning of the project all the way through implementation. As we look at also other things that were laid out with elegance on the project, you can see the interior lighting. Laid out lighting for outside views to give it something that's dynamic and architecturally pleasing, also providing proper lighting for the tasks going on in the space. This requires a lot of parties to get through that planning. And I think on most of our projects, if you don't have that, you're going to run into issues. The other thing we did with this, separate from just dealing with the fenestration system, we reviewed the HVAC system. We want to know where air was moving to get good conditioning in the spaces and to the people. Most HVAC systems are designed to condition space. They're not designed to condition for people. So you start looking at the layout of your system, layout of your controls, are you getting those feedback loops so that when people are asking for 70 degrees, they're not getting like 78. They're not getting overheating from the glass. How are you running the system? So that combination, looking at the low ceiling heights, creates a lot of challenges with looking at HVAC layout. So you need that building evaluation to look at that. And that's it. I'm trying to get you back on track.
Thank you so much. Oh yeah, we are getting back. I mean, thank you so much, Paul, for the couple minutes there. Well, let me introduce you guys to John from Boston Valley Terracotta. He's one of our sponsors, so give him a big round of applause.
Thanks, Angel. Okay, I don't want to bore everybody today, but I'm going to talk a little bit about terracotta. It's really on the comeback, and I think everybody needs to learn a little bit about it. You know, it's being used in unitized facades and precast concrete, things like that. So I'm going to walk you through a few case studies that we did. This particular picture here was a really big project that was just completed about 2 years ago by KPF in New York, and it was unitized by Prins. New York has a lot of terracotta, so I think architects are starting to study the surrounding areas and starting to see that brick and terracotta are a dominant building feature, and this is such a great building material. We need to expose you guys on how to work with it. It's back 1,000 years, so it's been around a very long time, as long as clay has been on the earth. But the beauty of the material is it's soft and it's plastic. It had a big comeback about 100 years ago in historic work when the Victorian era was generating a lot of beautiful architecture in New York, all the cities in the United States. And then more recently, it's been rediscovered. It's been rediscovered with its plasticity and flexibility, and also the ability to extrude it and make it very thin and lightweight. Hi, John. Maybe you take this. I don't know what's wrong. Okay. How's that? Better? Okay, sorry about that. So we're PCI certified. We had to go through a fair amount of testing to achieve that. That means that now we can integrate it in with concrete and ultra-high performance concrete. So we think that's going to be a bright future in designing with the material. We're trying to work with the groups that do precast to understand a little bit about how to keep the weight down on that material as well. But you're going to see that going forward, I think, in the future of lightening up the precast assembly. But this is basically the material is embedded right with a dovetail system right in the concrete, so it can handle all the pull-off tests, freeze thaw. So don't be afraid to design with it in precast. A great example that we did about 5 years ago, right here with ZGF Architects, who are in the audience, was this lovely little office building at 1200 17th. If you have an opportunity, take a walk by, look at it, really stunning project. I did not list the installation contractor. That was Modern Mosaic, Niagara Falls, Ontario, and the general contractor was Balfour Beatty. Very successful project. It was really efficient the way they designed working with the material, and it was kind of out of the box, but ZGF approached us and wanted to know if we can make these picture frames around the flat panel. And we said, absolutely, we can help you in a design assist on how that would work. So you get a great example of that dovetail system and how basically it looked before it was shipped to the precast facility. These are some of the details that we worked hand in hand with the design team and Modern Mosaic to fully realize all the different parts that were going to be needed to do the project. Several different angles, corner configurations, all that has to be properly detailed before you can release the material into production. I think what made this project extra special was the glaze finish that they picked. The developer, Bob Schofield, I don't know if Bob's in the audience, but Bob had a very particular vision of that color. So it took about 6 months to perfect the finish, and he couldn't actually describe it. All he could do was say, I'll know it when I see it. And he flew down to the plant one day and said, that's it, we're going with it. So it really turned out nice. These are pictures of the cast assemblies leaving the precast facility. Very efficient stacking system. And that's what they looked like when they came out of the casting plant. So this is really an efficient way to build, and it's got a lot of added value when it comes to permanence, blast proof, all kinds of things that I think people think about when they're designing buildings in the DC market. That's just a great shot with the symmetry of all the cruciforms, we call them. But again, the ease of installation between plucking them, getting them on the truck, getting them to the job site, not having all that clutter, and then instant installation was one of the advantages of doing this building in a precast application. And of course, the punched window openings allowed for this type of geometry to work. They actually featured stainless steel trim around those window frames, which really added an accent, a beautiful elegance to the building. Another job that we did recently with Arwen and Krouse was Pike and Rose, not far from here. This particular project, again, had a very tight deadline, but they were trying to design the terracotta to give it more of an expression as far as profiling and color. At the end of the day, I think they achieved the look that they were after. The spandrels are actually made of GFRC. They might have been precast concrete, I can't remember. All I know is we were fortunate enough to survive the value engineering that always happens with this material. But I think when you remove it from the context of the building, it doesn't come out as pretty. So yeah, you got to spend a little bit more money to get what you want, but at the end of the day, they're going to fill the building with the tenants because people are really attracted to this material. And that's just a close-up of some of the complicated geometry. With our background in restoration, we're very good at making very large profiles for extrusions, so we were able to accommodate some of these larger profiling shapes. The unfortunate part is it's very difficult to extrude them 5 or 6 feet in length and hold the tolerance. So the architect has to kind of work with us on the jointing scheme, but I think at the end of the day, we struck a pretty good balance. And then back to the performative values of working with architectural terracotta. It's got a lot of great advantages because it is a low carbon footprint material, which checks a lot of boxes for you guys these days with paying attention to the energy that's required. We are at the bottom of the food chain, or right in the middle. You can see it there. I just blew it up. So we're right there with brick, clay tile, gypboard, that type of product. So I think that's something that y'all need to know about working with this material. And we've fact-checked this several times. I've been challenged on it. We have a PhD who does some of our testing for us, and he went back and double-checked all these numbers. And in fact, we are right at the bottom of the amount of energy requirement that's used to make this material, which is also an added benefit. Now, clay is mined from the earth. It's naturally occurring. Our clay is sourced locally within a 350-mile radius of our facility. And then after they mine the clay, they have to put it back. I'll show you that in a second. We do have an EPD declaration that you can tie into your paperwork. This is downloadable off of our website. If anybody has any very specific questions about it, feel free to email our facility, and we have a technical expert that can help answer any questions that you would have. We do also recycle all the scrap that comes off the material, which is, it's a real feel-good thing if you're in manufacturing and are able to reuse this material. So what we do is we take all the cuttings off the end of the product and crush it and screen it and add it back into our mix. And then this is a kind of a fuzzy picture, but it's actually the mining operation, and after they're done digging the pit, you can't just leave it like that. So in the US, they have a Land Reclamation Act. So it really turns back to a park-like setting when they're done harvesting the clay out of these pits. Another thing that we offer with our product to help architects understand the possibilities of how to design and work with it is we offer an ACAL workshop, which stands for Architectural Assembly Ceramic Workshop. And we typically bring in anywhere from 6 to 8 teams across the country. This year we have ZGF participating in it, who's in the crowd. It's a lot of fun, but at the end of the day, everybody's learning, especially the students, because it's research oriented. And they bring the models, and we manufacture all the parts from their design, and then they assemble it the second week of August at the University of Buffalo. We also have Miss Janney featured in here, who's been working on some cutting-edge research as it relates to lightweight extrudable cornice work that can be hung in a rain screen application. Another great example with high performance building is this is a combination of a stick-built assembly system where we provide all the necessary hardware and track and clip at the ground level, and then the upper floors were done in a precast application. So we had two different systems that we used in this particular job to execute this beautiful Hyatt Regency out at Tyson Corners. And this is just a great shot of the building going together. Again, the efficiencies of working with a precast concrete, the erection and speed at which it goes up is phenomenal. And then the detailing can integrate nice looking metal trim pieces in the sill to kind of take care of all the little tiny details that have to be considered. So you have all kinds of options to work with. On this particular job, we actually had a little jam return built right into the design. And that's a finished shot of the building, and I think it turned out really nice. Again, part of the research that we're doing at the Assemblies Workshop are all kinds of different designs are coming from the leading architectural firms as they relate to performance, screens, energy savings, bringing light into the building, the type of research that needs to be happening all the time so architects can understand how they can design with this material. One of the workshops that we participated with Combe Pedersen Fox on was a very beautiful design for precast concrete using the ceramic elements in that. And they actually came well prepared and did their own digital models. And that's the team, all happy, taking the models apart, and then we built all the parts for them. They actually came to the facility to understand how to texture the material and what the possibilities were in working with it. So they were very interactive with their project. And they designed different texture rollers that fit right into the profile of the extrusion. So they were exploring what the glaze would do when it melted into these different textured pockets. So it's not just a straight extrusion, it can be very customized with very little effort. But I think what's really rewarding for the design team is they actually get dirty and are shoveling the concrete into the formwork, so they really understand how the stuff is built and goes together. And then at the end of the day, you can see the quality of the work. It's absolutely stunning. Thank you.
Thank you so much. Thank you so much, John. Actually, a little fun fact, a lot of embassies and consulates are designed with terracotta. That's right. And with, you know, substantial security requirements, it's pretty amazing that this material does so well.
We're not allowed to talk about it, though.
Yeah, we're not. These guys will keep it close, right? Don't tell anybody about that one. Let me introduce a couple folks that I've worked with in the past. Martina and Daniel from West Janney.
Let me see if this is working. Try not to thrash about. My name is Martina Driscoll. I'm a civil engineer by training, a principal with WJE in our Falls Church office, but the career has been spent on building enclosures, existing and new construction problem prevention.
And my name's Dan Lemieux. I'm a principal with West Janney also. I also spent my career in enclosures. I'm a director in
Too close to me.
international operations group. And
we're here today to talk about office to residential conversions, or office to resi, as the cool kids say. It's a hot topic, you know. It seems like everyone's talking about it a little bit. The next presentation after ours is about a conversion, and you know, Paul's presentation kind of speaks to this issue, as does the discussion on sustainability. So is this a new thing? In short, no, it's not. We've been doing adaptive reuse for years, right? But what is new is the impact of the pandemic, right? The increase in office vacancies due to the pandemic resulted in what they're calling a flight to quality in office buildings, where people are leaving Class B and C office space to Class A and trophy office space. You know, in addition to that, there is a sustained goal of sustainability and, you know, embodied carbon reduction, and adaptive reuse is sensitive to that. And you throw historic preservation in there for some of these buildings, and it's a pretty compelling case, right? So why aren't we doing it all the time? Well, is it viable is a question I think, you know, all the developers in the room would ask. And Gensler has done a lot of work in trying to kind of quantify this decision-making process. So anyone here from Gensler, thank you. But this is one of their slides, but you can see that they've tried to kind of formulate this by considering these 5 primary criteria: site context, form, floor plate, envelope, and servicing. Interestingly, they've done a lot of work on this, over 300 buildings they've studied across the nation. They've had a lot of success with conversions in Calgary. And the takeaway that I took from the several articles, great articles that they've published on this, is that about 30% of the buildings that they looked at were actually kind of a fit for conversion. And that, I think, is in the context of this, of these criteria. We're going to start, we're going to give you a couple of case studies to talk through some of the issues that are involved. Dan's going to start in London because that's been around for quite a while.
Sure, thank you. So yeah, we're going to take a little bit of a detour. A lot of my work has been focused on supporting our group in London, in our office there. We've had the good fortune to work with a developer in London on a project in Croydon, which you see there with the orange arrow. Try the spotlight there. Croydon, working class neighborhood in London, just south of the city of London. And the developer there has an asset where they have hired us to help them, or hired us to help them in Reba Stage 0, Reba Stage 1. This is functionally schematic design, and helping them to explore some of the options they have to upgrade their property. So East Croydon, as you can see, this is again a working class neighborhood. The building stock in East Croydon is 60s, 70s type buildings, so particularly ripe for office to resi conversion. What you see here, obviously the image, and then some of the feedback that in the press, it just feels right? It's culturally, it's the right thing to do. We have a housing crisis in London, like a lot of major cities, and so this is really the right thing to do. We have office properties that are a little bit obsolete. So again, this is what's happening in the city of London. Savills did a nice job. This is back in 2013. So this has been happening in London for over the last decade. So Savills took a look at this. What is the potential uplift to go from office to rent? How does that affect the value of the property? Is this a good investment? What is the return on the investment? And as one of the bullets there points out, no matter what we want to try and do in terms of policy, it has to be commercially viable. It has to make sense for a developer. When you look at London and central London, most of the markets outside of central London, which, if you think of high rent districts like Mayfair and those types of areas, when you get out to cities and boroughs like Croydon and further into the Midlands, the numbers get a little dicey, right? It's not quite as attractive as it may be in central London. So in 2013, what they did to encourage this kind of development is loosen up the rules a little bit. So the permitted development rights in London, they changed the policy a little bit. They removed the affordable housing requirement. They instituted a plan whereby with the relaxed rules in the PDR, that you could take an office building of any size and convert that to residential without being held back by some of the affordable housing requirements and some other things. You essentially could sidestep what had been the planning process in most of these boroughs. The option that the boroughs had was to apply for an Article 4 direction. So that was a chance for the boroughs to say, hey, wait a minute, we don't want unchecked development and conversion, right? We want to make sure that we're doing the right thing. We want to make sure some of these developers can come through a normal permitting process. The case study we have, you can see here, this is again in East Croydon. This is a 1960s office building, lightly occupied at the time. As we speak, it's in the process of refurbishment, not conversion, but refurbishment with our developer client. But you can see here, it actually already starts to look like a residential property, just aesthetically. So we had some 1960s original construction. Originally, it was mosaic tile that was exposed. At some point, probably in the 80s, it was overclad with aluminum. And you can see it's basically very discrete window wall bays and what used to be operable units that are no longer operable. So when we look at this property, this is a bit of a what-if scenario. So this is an office upgrade in process. Because of the topic, and when Martina and I talked about this originally, I thought, this is a particularly attractive target for office to resi conversion in London. So you can see here some of the advantages. We have narrow floor plates here. We already have two vertical circulation cores. We have the opportunity for double loaded corridors in each of these buildings. You can see areas for egress. So a lot of the things we look for in an office building for office to resi conversion, we already have at this property. In the office upgrade, like we would in office to resi conversion, we looked at all of the environmental considerations that you would expect, right? So we're looking for heat, air, moisture issues. What are our options on the facade? Can we just refurbish in place? Can we do an in situ refurbishment or a discrete removal and replacement, that type of thing? So we're looking at all of these issues that you see here. We modeled this. We worked with the architect in London and with the developer to try and help them understand these issues and how they relate to sustainability. So when you think of the East Croydon plan in the City of London plan. There's a net zero 2050 in London. A lot of the same sustainability targets that we have here in the US is what they're looking at in London. So keeping a very close eye on that. And when we think of the cost of the enclosure as part of the office to resi conversion, this was the driver. An office upgrade and an office to resi, the cost of the enclosure was in fact the go, no-go key point in this thing. So we did work with some Schuko systems to try and get pricing. So we're looking at different options. We're looking at triple glazing. We're near a rail station, so we're thinking about acoustics. We're thinking about ventilation, all of those types of things. When we looked at this, you can see again, we used sort of traditional stoplight approach for a presentation to the developer about what we felt, where is the sweet spot here in terms of the enclosure and what makes the most sense. So in an office upgrade, what we determined was unitized curtain wall made the most sense. We shortened the construction time, we weather in the building, all of the things most of you are familiar with in terms of going to a unitized curtain wall. When we think about this from office to resi, it gets a little more compelling because when you look at new window wall, we're less excited about that in an office upgrade for construction duration, tenant disruption, that type of thing. But in an office to resi conversion, it would be quite desirable. So there's an opportunity here to, as you saw in the earlier image, to take the original window wall out. As you see the gentleman here leaning up a window wall on one of our projects, there's an opportunity there to do that, phase the project, move some tenants through to different spaces on that property. So is it a viable alternative? Again, this is a what-if scenario. When we spoke with some of the folks that were involved, we did talk to the developer before we sent them a copy of this presentation, talked to them a little bit. You can see in what highlighted here, when we get to 2020, 2013, 2014, Croydon is applying for the Article 4 direction. They're trying to slow the roll a little bit. They don't have that Article 4 direction right now. So by 2020, the local authority, if the developer had gone and spoken to them about a possible office to resi, they would have been open to it. This is something they're still encouraging in East Croydon. And you can see, and we'll talk more about this, and Martina will cover some of this as well, that again, good access to light, narrow floor plates, all of the things we just spoke about. This is a particularly attractive project. So, and you can see here in the image, this is a rendering by the architects. You can see where it's relative to the rail station.
I think it's interesting here too, Dan, the second bullet, which really focuses on maybe a downside of that push, which was, substandard residential, to some of those conversions in London. Yeah.
And that's a good segue to this slide. So, by the time we get to 2019, questions will be asked. I mean, I think there was a lot of pushback. By now, we had some office to resi conversions that didn't work. You had pretty strident commentary, particularly from the architectural community, about what happened in some of these conversions. And so, it's really relying on developers to do the right thing, and it's trying to find again that sweet spot between cultural, what we desire culturally, what we're trying to do in our cities, and how do we legislate that? How do we properly regulate that to achieve what we're trying to achieve? So today, you can see this again as these are the targets. The one thing I wanted to talk about here is this EPC time bomb, if you will. So there's some concern now. In London, we're going to have to hit these targets on that timeline. So if developers don't move quickly to take advantage of that, they're maybe stuck with assets that it's too costly or it's cost prohibitive to upgrade the enclosure to accomplish the conversion. So there's a bit of a race there from the development side, and then there's an equally strong race from a legislative standpoint with respect to trying to slow some of that roll a little bit, particularly in a borough like East Croydon, which, like a lot of areas of Washington and other cities, is turning over. It's slowly gaining a new identity as where it sits in London. So, quick lessons for London, and this is, what can this teach us about Washington? We're going to talk a lot about Washington here in a minute, but again, the road paved with good intentions. I mentioned we need to find a way in Washington, D.C., like most cities, we need to find that sweet spot. How do we balance cultural needs and commercial viability? The big thing we want to talk about, though, is the embodied asset, right? What do we have in front of us as a property? Is it in the right location? Do the numbers make sense? Is it commercially viable? Does the floor plate make sense? Does the enclosure transition make sense? Can we do something with the enclosure that's energy efficient, sustainable, does all the things we want to do? It introduces ventilation, all of those things, and where is that cost? And again, it can be considerable. These numbers come from London, but up to 20 to 25% of the total cost of the conversion. So these are real numbers and real issues, and enclosure is typically, at least in my experience, the driver for a lot of these decisions. And last, creativity and courage. It takes a lot of courage to move forward on this. We're seeing some of this in Washington. There's some of these office to resi conversions, so it takes a lot of courage to do that. We have a real housing crisis. We have climate change. We have a lot of things that office to resi conversion can help us with. Just need to be thoughtful about it, do it the right way. This is very quickly, this is 1 Wall Street, New York City. This was a project of mine back in the late 90s and early 2000s. This was, at that time, a very simple window replacement. This was a historic window replacement. It's a landmark in New York City. We worked with the Landmarks Committee to develop this replacement window product. The 9/11 attacks happened in the middle of this project. So 1 Wall Street, if you're familiar with New York, it's about a block or two from ground zero. So what's interesting here, and Martina will talk a little bit about some of the same tax incentives, but what we introduced because of 9/11 was laminated inboard glass sheet, structural silicone. As part of the replacement, we introduced that in the middle of the project. So a lot of the advantages that trying to convert this from office to resi, which in fact Maclo Properties have, and I think it just opened in the last year. You would have done the same thing with these windows, thermally improved, thermally broken frames, and acoustically the laminated inboard glass sheet. So we were very careful with our client to explain that that's not really quote unquote blast proofing your property, right? But it does offer some protection, but it really offers a lot of acoustic advantages. So again, all of the things we'd be looking for, and I'm sure they appreciated when Maclo went from office to resi. They really didn't have to do anything with windows. They are operable. We maintained the windows as operable units. So.
Yeah, and just interesting on the 421G, I won't spend too much time on it, but from 1990 to 2020, 1990 to, was it 2002? They converted about 13,000 units in Lower Manhattan using this incentive. That was about 40% of the new units that came online there at that time. Since then, office to resi conversions have continued in New York without that incentive, which is interesting. Also interesting is buildings built before 1945, like this one, were more likely to be suitable for conversion, I think for all the reasons that Dan just mentioned about this one, which was just fortunate that they had already taken steps towards it, unrelated to a conversion. And again, not to make it, I love how the one statement I have on my slides is all about the money, but this is a project in Chicago we're currently working on as part of a LaSalle corridor revitalization program there. Similarly to everywhere else, they're offering tax incentives to try to encourage these kind of conversions. The center building, I think circa 1911, historic property, you can see punch windows ready-made for residential. The floor plate's a little awkward, but they've made it work. The building on the left is a 1958, I think, SOM building. You can imagine there are going to be a lot more issues with the facade on that building with respect to conversion. One of the things we're working on now, and unfortunately, we had some sketches, but they're not ready for prime time yet, so we didn't present them. But one of the things that we're working on now are developing retrofit details for the existing single pane, glass, steel-framed curtain wall, right? You can imagine the temperatures associated with that right now. To introduce an operable light that includes ventilation, improved acoustics, improved thermal. So that's in progress right now. On to DC, you know, we're looking at that here, obviously. We had a huge dip in, interestingly, the vacancies in Class B office space were already kind of dropping before COVID in the city. They held pretty strong, but kind of fell off dramatically. Mayor Bowser is looking to institute, again, similar tax incentives for this. She's most recently tried to add additional tax incentives to the ones that are already being proposed. Not everybody's happy with this, because similarly to what happened in London is they are talking about removing some of the requirements for low-income housing. They are talking about removing the requirement for, you know, district residents having first choice at working on these kind of projects and all of that. So they're trying to make it viable, but of course that has some social impact. They did an assessment of commercial diversity in 2020 and found maybe one area that they're saying likely feasible at the time that this study was done. But I mean, that being said, we know it works, right? We've done it a bunch of times. You know, I think some of the numbers we've heard, Dan, are, you know, 250 to 350 per square foot for these conversions. That's approaching the cost of a new build. Obviously, they're going to need someone to make up some of those costs. The information on the right was we got from Avison Young, but you can see even for a Class C office spaces, if a developer is looking for numbers around 110, 130, there's still a lot of money to be made up there if those buildings are selling for 364. But it's worked in the past. We were not involved in this project or this project, but you can see the impact on the facade of these conversions. A lot of attempts to break up the massing, like we've heard from a couple others, introducing more verticality to sort of, a lot of these just, everyone that we're showing is an 80s office building conversion with the ribbon windows and all of that. And also the introduction of kind of a exterior space like balconies to make these things more attractive for residential. This one is so clear, right? Turning a big chunk of opaque wall into a glass box, kind of, you know, again, a lot of facade impact here. This is an 80s office building, very, very similar in Fairfax that we're currently working on. You can see in the rendering what they're trying to do something similar, introduce some verticality, introducing operable windows, introducing balconies. The floor plate looks pretty good, pretty promising, you know, kind of a central core. You've got some pretty deep units, so the inner portion of those units may be a little dark, but, you know, viable. The enclosure has a lot to be desired, however. These 80s office buildings are designed as a barrier system where you basically just have granite panels and that's it, and sealant. And, you know, 3 inches of bat or something, which doesn't even come close to the, you know, that's like an R8 or something. So one of the things we're looking at doing maybe is almost like a tilt-up approach where we'll take down those knee walls, apply mineral wool insulation to the exterior, and then sort of tilt them up into place. Obviously, you have some discontinuities there. You can't really put like a weather barrier or flashing in, but part of what we're thinking about doing is maybe introducing a membrane variable permeability retarder to the inside. You don't need it by code for a vapor retarder standpoint, but we're trying to control some airflow into this space. So those are some of the things that we're looking at with this project. Obviously, complications arise too when you are trying to insert new non-barrier style enclosure elements into a barrier assembly. So a lot of transition detailing here, a lot of structural modification to support the balconies. When you open up things like this, you find things like missing smoke seals that also need to be addressed. So the costs rise. You also need to think about the fact that you are going to have to introduce louvers and ventilation for all the new stuff that you're putting into each of these units, kitchens, bathrooms, HVAC, units. All of that needs to be factored into the cost and into the aesthetic of the new building. But it's viable. They're working through it. So what have we learned through this? With a minute. The majority of the projects out there will not be viable, just considering those 5 basic criteria. In any high-cost urban area, most of those projects that work from a layout standpoint may not be viable without significant financial incentives from the localities. Conversions may need to be controlled through statutory regulations, particularly if low-cost housing is a goal. You know, if we really want to stick to that, we're going to have to get creative with these incentives. And as Dan mentioned, enclosures can be a significant part of that equation, 20 to 25% in some studies. And modifications to address thermal, comfort, efficiency, aesthetics, a lot of what Paul talked about, natural ventilation, they can be a go, no-go factor in these decisions.
Yeah, agreed. Really understanding the built asset and again, finding the sweet spot, right? And it has to be commercially viable for this to really go.
Yeah.
So.
Thank you very much.
All right, thanks, guys. We're doing great. These guys have been finishing early, which is exactly what you want as an owner, so that's wonderful. You guys deserve a little break, so you're going to get one right now. Come back at 11 o'clock if you don't mind, so we can get the next round started. All right, thank you. Thanks for coming back on time. We're doing really great, so no worries here. Just a reminder for all the speakers that are coming up, if you don't mind just hanging out until the end of the session so that we can take photographs with you with some, what's the right word, awards? Mementos. I almost said tchotchke, but I think mementos a better phrase. All right, so let me turn it over to Thilo from DPR.
Thanks, Angel. Yes, I'll be talking about a project here that is not too far away from here, 20 Mass Avenue. Again, I'm Thilo Wilhelmsen. I'm an exterior envelope manager for DPR Construction. Previously worked in the facade world with Joseph Gardner, part of Prins Group before turning to the dark side, I guess, 5 years ago. I divided the presentation into it's kind of talking about what we inherited and what we have with initially. And then also talk about the facade systems that were employed throughout the project, and finally taking you through some of the challenges and lessons learned on the project. So first part, the transformation. For every great project, we need a great project team. RMR Group was the owner. I don't know if they're represented here today. Leo Daly, the project architect. Strong contingency here in the room today, thank you. We obviously were the construction manager, and then also were supported by WSP. Paul was here earlier, and then SKNA was our structural engineer. So curtainwall design assist partner, curtainwall, Utah's curtain was the majority of the exterior envelope, was Pioneer out of Mason, Ohio. And so let's look at the existing, or the previously existing building, I should say. It was an 8-story government building, clad in beautiful precast with punched openings in close proximity to Union Station and also the Capitol. There's a little bit of curtain wall already on the east facade, but this is kind of what we had to work with. And so we had to strip it down, of course, and so you can see a shot here of the skeleton of the building. Took it down bare bones, also took off the roof slab, and then here on the bottom right, you can obviously see some of these beautiful precast panels that we had to take off the building. The scope was, you had basically a 3-story overbuilt on top of the building to make it basically a 10-story building with almost double height penthouse. And then also there was an addition to the east facade of the building as well.
So this was the vision, one of the earlier renderings from Leroy Daly. Can clearly see what was intended for the building. And so we ended up, the building is actually about to be completed in the next few weeks with almost 500,000 square feet of hotel and office shell space. We also had retail and restaurant space on the ground floor, a rooftop amenity. We created 2 new atriums, one of which we're going to look at a little bit closer a little bit later. And I think what also was worth mentioning is that we had over 200 shore pad bathroom pads that went into the hotel portion of the building. So all in the spirit of prefab with unitized curtain wall. And then also I'll be talking about some other prefab opportunities in the building later. So let's talk about some of the facade systems. I'm just going to walk you through what we see on the building nowadays. There is the unitized curtain wall, which has some features such as terracotta, some external horizontal and vertical fins or extended caps, if we want to call them that, and then a shading component on the north elevation of the building. Excuse me. Terracotta had to be one of the very early topics that needed to be discussed, just simply because this entire project took place during COVID, and lead times, as many of you know, were very challenging. So we had to look at different colors and textures very early in the process, and then ultimately ended up with a product from NBK that we see here. So unfortunately, none of the sponsors that are here today are on the building, but that they're all great products and all great companies, of course. So the integration into the curtain wall was also that the terracotta got unitized into curtain wall frame as a rain screen system, as you can see here. There we go. Basically the weather barrier was an 8-inch aluminum plate sealed into the frame, making it a weather-tight system. And then also you see here a section of the vertical fin that was about 7.5 inches from the surface of glass. Again, MBK panel here in section was a really nice product that we used on the project. We also had to deal with some horizontal and vertical setbacks that were part of the design of the building. They occurred in 4 different locations on the north and south elevations. On the top elevation here, you can see they were to the right and left of the hotel entrance and the shading feature above. And on the south elevation, we had 2 column lights also where the step back and transition to a different unitized curtain wall system. In detail, that looks something like this. Here again, this is right above the hotel entrance. You can also see the shading component that I talked about earlier. So there were certainly some challenges with that. It had to be thermally proved out that this is going to work for us. And in addition to that, obviously had some waterproofing challenges, as these are not just simple vertical mullions that typically just get snapped together. So we had to basically set it back and then we'll seal and joint take care of the waterproofing for us. Unfortunately, I actually highlighted the wrong side of the building. This should have been this side, but I think you get the idea. So let's see here. So, and then I talked also about the horizontal setbacks. They occurred on the transitions between the 2nd and 3rd floor, and then also between the 8th and 9th floor. Again, challenges with, making sure this is a waterproof system. Also, we had basically a starter sill that had to be, installed above a regular curtain wall unit, and then basically the offset curtain wall above, either protruding from or recessing from the pane below. So that was certainly a challenging detail to deal with. Canopies. We also, above the retail level and the ground level, had some canopies of varying depth protruding out of the building. Very challenging as well, as we had curtain wall transitioning into a canopy condition, then it transitions back into and then again into a store condition. So a lot of different trades had to be coordinated. Our curtain wall contractor took care of basically the exterior skin, but waterproofing, insulation, and then also steel supports for these canopies had to be coordinated very early in the process, and make sure that all of this comes together the right way. Oh. Here we go. Shading, this was also another component, design component, like I said, above the hotel entrance in the north elevation. It basically consisted of aluminum extrusions that were fixed to the curtain wall onto knife plates that came out of basically the vertical mullions extrusions. And so again, had to deal with some of the wind loads, and then also waterproofing issues that needed to be resolved. And so again, one of the more challenging components on the building, and then it also transitions into a canopy situation below, which I'm going to mention a little bit later in the presentation. Here we go. We have a large interior glazing scope. We're looking at the west atrium that had a large skylight above, which I'm also mentioning later in the presentation. So there were about 5 floors of interior curtain wall application that had to be dealt with, and then also punched window openings below between metal panel features. So this definitely was a challenge in terms of logistics and also sequencing of the project, as we obviously had to complete some of this before the skylight was complete. And then the systems on the projects consisted of some storefronts. We had a 20-foot tall storefront that was installed in the curtain wall configuration up on the penthouse level over here. Some folding walls also on the penthouse level, and then of course on the ground level we had miscellaneous storefront conditions as well. So again, this is just something to complete the scope on the exterior envelope. DPR's self-perform group actually also had a prefabrication opportunity on the project. So we actually, on the west elevation, had metal panel finish openings. And so the backup walls were prefabricated on site on the ground floor. So studs and sheathing, waterproofing was pre-installed and hung onto the building, and it really helped move forward the building in terms of schedule, and then also was very cost effective to do that, and so very, very successful execution here. There we go. And then I talked about skylight, and then also there's porte cochere. Porte cochere is a fancy word for canopy, I've learned. The skylight portion was taken care of by Novum Structures. I'm not sure if anybody's here from Novum here today. Again, above the west atrium, you can see here on the right side a little bit. Here we go. Some of the completed curtain wall, interior curtain wall already. And I also have some pictures here during installation. So you can see the steel supports which ran east-west on the project, and then the purlins for the glass support ran north-south. Glass was supported with patch fittings. And so it definitely came together very nicely. I talked about the porte cochere a little bit as well. So this is Again, canopy above the hotel entrance, protruding, cantilevering about almost 20 feet from the face of the facade. No tiebacks to the building, no columns, so definitely had some structural challenges. Penetrations through the curtain wall, of course, so that we had steel girders, suspended glass with point fittings. Another challenge was matching these, there we go, matching these aluminum extrusions to what was going on above here on the sun shading so that they matched in color. So yeah, very, very nice feature, very successful execution from Apartment Novum here. So this was basically all the scope, all the exterior envelope scope in a short overview. So now I want to talk about, obviously there were some challenges. I mean, Paul talked about some of the challenges with reclads. So I think we're picking up some of the same topics here, but I think it's important to go through that, and as we're going to see more and more of these buildings coming into play. The delivery method for curtain wall, again, was design assist. So we started the process about 3 years ago, awarded the project about 2 months later, and then it took about 17 months to get from design assist award to getting materials on site. That may sound like a very comfortable duration, but again, this was COVID, and with lead times creeping up, especially for aluminum, terracotta, it was quite challenging to get there in that period of time. I mean, now I would have said, but at the time it was actually quite a challenge to make it, and we successfully did it. We also had a PMU in there, which I'm going to mention a little bit later, which also obviously added to the entire timeline quite a bit. So some of the challenges, I think Paul mentioned that earlier as well, was concrete slab strength, uneven floors, some inconsistencies on the slab edge, getting the team aligned early in the process, and then, just really aligning the design and the scope and coordinating that as early as possible. So let's talk about the slab strength, sorry. So some early testing was done throughout the building, and we discovered that some of the slab strength was below 2,000 psi, which was very concerning to us because the minimum strength required for the curtain wall anchors was 2,700 psi. So that definitely presented some headaches at the early stages of the project. So we had to do some core drill tests strategically placed throughout the building on different floor levels, and to make sure that we have in fact enough strength in the concrete to absorb wind load and dead load requirements for the curtain wall. So we found actually that we were just about enough strength with the 2,700 psi in all of the required locations. But in addition to that, we also had a number of pull tests performed, so just to make sure that what we're testing is actually also performing. So definitely something you want to think about when you're recladding a building. All right. I'm not advancing here. Technical difficulties, I'm sorry. Here we go. Floor leveling, sorry. That wasn't that much of an issue actually for the curtain wall itself. I mean, that's basically was something that had to be done throughout the building. There were some areas certainly that were close to the perimeter, but for the most part, it was just an overall challenge that you'll run into with a building of that age. I mean, the building goes back to 1973, I believe, and it definitely there were definitely some inconsistencies. What worried us more is, if I can get to the next slide, I can tell you about it. in the slab edge. And on the right side, you can see a very exaggerated red line of what I'm talking about, which was basically that the building kind of stepped back as we went up the building. The slab edges were up, off by 1 to 3 inches in some locations. So that really presented some issues and made us very nervous for a period of time, because we thought that we may have to add some steel to the slab edges in order to make up for the difference. But we also performed then, together with Pioneer, our curtain wall contractor, some additional surveys and found that, with some anchor modifications, we were able to absorb that. And then also, of course, the curtain wall is able to absorb certain tolerances. So overall, it fortunately for us worked out, and we didn't have to have any additional measures, which would have obviously had a very negative impact for the schedule and also in terms of cost. So lucky there. The PMU, we had a very large PMU that was performed at Pioneer's facility in Ohio. Learned a lot of things. I think it was actually a very good process, and I think it was, it was really the basis for the success on the building, really. There are a lot of the conditions that I talked about before with, step backs in there yet. And it was a very large mock-up as well, included some of the terracotta, like I said, some of the vertical and horizontal setbacks, corner condition, 2.5 stories tall. They actually built a test cell just for us. It was very cost-effective testing at their facility. And I think one of the advantages also we had is that, some of the things that need to be corrected, and, there were some, we were able to do that pretty quickly because we had staff and materials right there. We were right at the source. If I had one criticism, it was probably because it was, you can see that small fan there. We had to dissect the entire mock-up into 6 sections, 6 zones, and test individuals, so everything had to be run again. And that just took time. And, at a third-party testing facility such as Intertech, they have one big fan, and, you can definitely save a lot of time doing it that way. So, but again, overall, I think this was just a very critical component of the project. And, we learned a lot. Next, yep. And then just continued testing. From day one, really, we see that the red rectangle there on the bottom. Those were some of the first units that were installed. They were immediately tested. And then as we went up the building with curtain wall, here we go. We just continued testing certain areas. And again, also some of the areas that were challenging was the setbacks, where we had some concerns, because those were really not the typical areas, and we needed to make sure that those perform as expected. So in summary, it really helped a lot having a critical trade partners such as curtain wall and structure onboarded very, very early in the process, making sure that we clearly delineated the scope and had a coordinated buyout for, the curtain wall, again, steel, waterproofing, insulation, fire safing. There's so many things in areas of the building, and just making sure that those are bought out early in the process and, covered, and so we don't have any scope gaps later on the project, and people are scratching their head and things are not going together as they should. Understanding of supply chains, I mentioned terracotta before with a very long lead time. Aluminum at the time was a concern as well. And then glass, actually the porte cochere and the skylight had glass from China, and definitely had some challenges there. Can't emphasize enough the mock-up. I think I talked enough about it, and then the continued testing just to make sure that the quality that we're expecting was adhered to. And so that was really, key to the success of the building. And then finally, just wanted to wrap it up by saying, here we go. you know, these type of projects, like Paul said earlier as well, I mean, more and more we're going to see these reclads. There's old buildings all over the United States and cities, and you know, this is something we're going to have to deal with. And I believe, you know, bringing in the general contractor, in this case us, and some of the key trade partners as early as possible is just key to the success of a building like this. And then collaboration with the entire project team, the design team, consultants, you know, the trade partners is just critical again. And then finally, you know, having an owner with a vision. You know, you saw the building at the beginning, and not many people probably would have thought, oh, you know, this is what I'm envisioning when I look at this precast building. So in that sense, you know, it really takes a leap of faith, and then also trusting the process. And so I certainly was very happy to be involved in the project. It was very challenging, and like I said, it's almost at the end now, and yeah, very happy to present that to you here today, and thanks for listening to me. Thank you.
Thank you, Thilo. I think that's the right way to end on a slide when you're talking about the owner's vision and trust. I think I'm a big fan of that one. So let me turn it over to Brendan from Costantino. Brendan?
My name is Brendan Mercier with Costantino. Today I'm here to talk to you about sustainable facade design with Totten, which is our ultra-compact stone product. Slide. So today we're going to talk about who Costantino is as a company, a lot about sustainability. It's been a big focus. It's a big focus for us as a company. What Totten ultra-compact stone is and how it can be integrated into different facade systems, and then go just through a few case studies before we turn it over to the next crew. Slide, please. So Costantino is a global family-owned company. We are in about 150 different countries. We are located in 50 different cities here in North America. Our corporate office is in Coral Gables. That's where I'm out of. I help run the facade department for our East Coast, but we are in pretty much every major city in North America. And so we have our own full distribution network. We manufacture our own products, and so we have a full sort of integrated process that we are control. So today, I'm going to talk a little bit about sustainability. It's a big focus for us. It is probably been the biggest focus for the last 3 or 4 years within our company. And a lot of times there's a bit of confusion around what does it mean for different companies and different people. And for Costantino, you know, it first starts with the environment. So environmental aspect for us is, you know, essentially creating a carbon neutral product, having an efficient manufacturing process, and then having a circular economy within our factory. So we recycle and upcycle almost everything that goes through our Totten factory. We have our own waste management and recycling plant at our factory, which is very, very uncommon for most manufacturers. So that gives us the ability to upcycle and recycle materials that go through the factory. From a social standpoint, we know that environmental is to help the future, but if we're not helping people that are actually working for the company, having fair trade practices, and ensuring that you're working with companies that have similar values to you, then you're not looking out for the people that are actually here today as well. So I think when we talk about environmental and social, they're very much integrated together. And then the government side of it is, you know, transparency, right? What are we doing as a company to show that we're not just saying we're trying to reduce our impact on the environment, that we're trying to take care of people, but what are we actually doing to do that? Slide, please. So here you can see from 2018 to today, we have reduced our carbon emissions by 6.6%. And it sounds like a small number, but if you consider how much Costantino has grown as a company, we've grown almost 40% as a company from 2018 to 2022. And with that growth, we've still reduced our overall impact in carbon emissions by 6.6%. So that's a huge win for us. In fact, that was 2021, so we've reduced that even more now as we run into 2023. The interesting thing about carbon emissions is when we talk about a carbon neutral product, most people are just offsetting carbon emissions through public works projects in the manufacturing phase. But as you can see in this slide, most of the emissions actually happen from raw materials, from delivery, and end of life cycle of use. So in Cosentino, we're not just calculating our carbon emissions per factory, but we are calculating our carbon emissions through the entire life cycle of the product, and then we're offsetting those carbon emissions projects around North America and the world. Next slide, please. Here, I've mentioned a few of this, but our factories run 100% off renewable energy, which is very important. We don't have any new water that is bring into our factory. Everything comes from recycled sources, so rainwater that is recycled, and then 99.9% of the water that goes through our factory can then be recycled and reused through closed-loop water filtration systems. So we're taking very much care for what goes into the factory and what comes out of the factory. Next slide, please. Here you can see that is that is our plant with our entire area, and those are a large solar array, so 100% renewable energy used at our factory. The solar array on our property takes about 15 or 20% of all of the electrical use of all of the factories, offices, logistics facilities, et cetera. So we're hoping to expand that in the future and hopefully one day be completely self-sufficient within our factory from an energy standpoint, from a water standpoint, from a recycling standpoint. We really think it's important to have a very circular economy that we can control right there within our factory. And if you ever want to visit, just come see me after the show. So what is Dectin and what is an ultra-compact stone? Next slide, please. It's really a unique product. It's kind of new to the market. It is a product made with just natural minerals, so all of the composition of the body, all of the veins, all of the colors, all of the patterns are all made from natural minerals. So those minerals could be quartz, quartzite, talc, feldspar. What we do is take those minerals, we break them down into like a dust form, so into a very, very small, and then we add a dry pigment to them. You can go to the next slide, please. But the important thing is that there's no resin, there's no bonding agents, and there's no organic materials. So nothing that's going to break down, fade, or degrade over time. So we take this now colored mineral dust, we put it into slab form, we compact it under 25,000 cubic tons of pressure. That's something that sets us apart from manufacturers. Sorry about that. I'll try to make sure that this stays in front of my face so that you can hear me. But so the press is 25,000 cubic tons of pressure. The benefit of that is it's compacted stronger than any other product on the market. And so that helps to reduce the porosity, helps to reduce the thermal expansion or almost make it zero. And then we add a second decoration process where we can take a digital image and essentially print any design onto the slab. But it's like a 3D printer using mineral dust. So again, there's no organic matter and nothing that goes into the product that's going to be faded or degraded. Then it goes through these large ovens, which go up to about 2,200 degrees. At that temperature, the minerals start to liquefy and they bond on a chemical level. So just heat and pressure, very similar to how natural stone's made in Mother Nature, but because it's done in a controlled environment, we're reducing the porosity, we're reducing the micro defects, the pitting, or eliminating completely, and all of the veins where you get some weak points in stone. So now you can use a very thin, very strong stone that's not going to stain, not going to degrade over time. Next slide, please. So here you can see some of the benefits of that manufacturing process. It is a non-combustible product. It is pretty much graffiti and stain proof, so you can use it down to grade, water, grime, dogs, humans, whatever that you might react to in a city. You're not going to stain the product, you're not going to damage it. Graffiti can be washed off with soap and water, or you can use some sort of cleaning solution, but very, very durable, high impact resistance, high abrasion resistance, and of course, carbon neutral cradle to grave with a 25-year material and finish warranty. And you can kind of see those pictures on the slide. Those are custom colors with a gloss finish that were made for that project. So also an opportunity to do some really unique designs with a customization. Next slide, please. Next slide. Thank you. Large panel format. So we have two panel sizes, 56 by 126 has been our standard for many years. We just introduced a third production line, which not only doubles our capacity at our factory, but allows us to make larger slabs, which are 64 inches by 130 inches. with thicknesses ranging from 4 millimeter all the way up to 30 millimeters. So you can use it for a lot of different applications. Depending on the type of facade system that you want to use, we may use a different type of thickness, and then you can kind of see the weight there, very, very light and thin stone, which is nice at a very large format. Next slide, please. So we have about 70 standard colors and finishes within our palette, but as I mentioned, starting at a pretty low amount of square feet, you can do customization, which starts about 10,000 square feet, and we can do full customization, or maybe we can match an existing product that doesn't exist anymore, like an existing building we need an addition. Whatever the case may be, there's a lot of unique possibilities. We've recently introduced a lot of limestone and travertine, so alternatives to natural stone that look very much like its natural counterpart without that porosity, without the degradation of that natural stone over time. So you have a really beautiful looking natural stone facade with a much more durable, lighter alternative. More cost effective. Touched on that, so we'll skip that last slide, okay, we now know what it is, ultra compact stone, Decton. Now how does it actually get attached to the building? So it can get attached many different ways. I think traditionally we see a lot of people using rain screen, ventilated rain screen design. We are part of the Rain Screen Association of North America, if people aren't familiar with them. They're a nonprofit organization focused on rain screen design and proper rain screen design in North America. Can also be integrated into curtain walls, which is great. Get into that here more in a second, and then also directed here. So if you're just going up 1 or 2 stories and you just want to install it like a tile on a mortar, that is not a problem as well. And then it can also be used for a precast skin if you want a little bit of a better, more durable product finish. Next slide, please. I'm not going to go through every system now, but just to give you an idea of the breadth of system offerings that you can have with this product. Essentially, we have a type of system for every design intent, type of system for every budget. So really what your project needs will help with the technical assistance there, will help with as much of the delegated design as you need, and will help to suggest a system that works best for your project. Next slide, please. So just some basic details for curtain wall. Can do captured, traditional, or structural silicone glazed curtain walls. So installed very similar to glass with just your structural adhesive. Also can be installed into unitized construction. And of course, if you need us to do edge kerfing or grooving for mechanical attachment on top of the adhesive, we can do that as well. So a lot of options, but we do have projects we are being just glazed in very similarly to glass. Next slide. Panel optimization, so color and maximizing the use of a panel is going to help your project meet its budget constraints. So of course, if you're using 90% of the panel, that's going to be a great use. If you're using 60% of the panel and wasting and having to throw away 40%, well, first of all, it's great that we can take that 40% and we can recycle it. We can either reuse it in future product, or we can recycle it and upcycle it. So any waste that goes through our factory, we do reuse, so it's not actually waste, but it does then, increase the cost, because then it takes a lot of time and energy to reuse that. Design Assist, which I mentioned, so delegated design will help with panel layouts to optimize your design and help to meet the budget. You can see here, we'll do a full takeoff with our technical design team in Spain. And then here locally, we have a full project management team as well. So we're here to help you make sure that you meet your budget and design considerations. Generally speaking, at our factory, we cut all of the panels to size. We drill for the anchor holes or for whatever mechanization that you need. And so the panels come ready to be installed by a local installer, either through our installer network or through your builders or contractors' needs. So I'll just go through a few projects with the last few minutes that I have here. This was a unitized construction product in Germany called Cap West. Over 135,000 square feet of material. You can go to the next slide. And you can see how we integrated these panels into the unitized system, helped with the design and how that was going to be installed, and worked out really well. So those large unitized pieces just got hung one piece after another. Obviously, unitized construction is becoming more and more popular here in the United States because generally faster, generally less expensive. 8XM Park in Vancouver, really great project, one of the tallest projects in Canada to date. This was a multi-residential mixed-use project, and all of the gloss white panels on that and some of the light gray panels were also ultra-compact surface. Another tall project in Vancouver, this is the Pacific by Grosvenor, so all of the balconies, all of the accent pieces going around the building were decked in ultra-compact surface. Next slide. One of the largest projects to date is the Toha project in Tel Aviv, Israel. This was done by Ron Arad Architects, over 300,000 square feet. So everything that you see in this picture that isn't glass, any opaque surface, was done in decked in 6 different custom colors, 10,000 unique cut tickets, all done at the factory. And you can see, so the first 6 floors of this building, they wanted to have all of the air conditioning, all the electrical units, so they could use the top floors for roof decks, restaurants, bars, social areas. And so we helped to create a unique design where we have an X shape, so it allows passive airflow to go to and from. Next slide. Last one here, the Rafael Nadal Academy in Spain. So the blue color on the outside of that building was a custom color. And then, you know, as I focus on facades, the product can also be used for a lot of other applications, be it pedestal floors, in and around swimming pool decks, countertops, flooring, interior wall cladding, you name it. It is a unique and universal product that can be used for any vertical or horizontal application, but facades are certainly the most fun. Next slide, please. And that's it. So again, I'm Brendan with Cosentino. If you'd like to go to our facade website, very easy, cosentino.com/USA/facades. And if you have any questions, we have a booth outside that we'd love to see you at after. So thank you so much. Really great talking to you and being here.
Thank you, Brendan, and thank you so much for being adaptable with our technology. That's I know it's tough sometimes. Next up, I want to introduce Amanda from KPF and Kahlil from Skanska. They'll be carrying us towards our first panel.
Hello, everyone. I'm Amanda Prins. I'm a senior associate principal and project manager at Cohn Fox in New York. And today, Cohn Fox is a unified architectural practice in New York that works on a variety of building typologies and scales. But today I'm here to talk along with Kahlil from Skanska about 1700 MDC. We're going to talk about how the inside-out design approach allowed for the dynamic realignment of the DC city block, as well as successful leasing strategies and the flexible facade approach going into the project. But to start off, I'm going to let Kahlil talk about Skanska's approach to development of the project before I dive into some of the planning and design.
So yes, like Amanda said, my name is Kahlil Francis, Development Associate. I also used to be a former architect, so I'm here to talk to you a little bit about the dark side. I'm kidding on that one. But really, Skanska Development is a global development construction firm. We work on multifamily office, primarily for the development side. And I'm going to be talking to you about our building, 17M. 17M, it's located in the Central Business District in downtown DC, so we're between DuPont Circle area and going up towards 18th Street. The building is about 330,000 square feet, 11 stories, a penthouse. And we're currently anchored by Gibson Dunn, who occupy the upper half of the building, along with UBS, who's occupying the 5th floor. So we're really happy to have them, and we're having a lot of good traction as a result of some of the strategies that we've implemented with the help of KPF. This is planned location of the building. We're right across from the National Geographic building, on 17th Street. So from Skanska's perspective, we actually started this right after we acquired the land. There's actually a multi-step process before we actually got in contact with KPF. So the idea being that we provide a framework for KPF to work towards. And these are some of the we're focused on as we started to develop the project. And so the key goal here is how do you provide security, privacy, and flexibility? And I know flexibility can work, but there's a reason for it. So talking about that approach, what we're really trying to deal with is what's called the Murphy-Top effect in DC, if you're not familiar with it. It's a kind of phenomenon that happens when the top of the building is leased first and the bottom part of the building has a hard time getting leased. So what we tried to do was on quality and flexibility for our tenants. So it's a tenant-focused design from the inside out. So what the approach allows for is to create a quality of space throughout the stack of the building, which means that the top gets your prime views, but at the bottom we're offering another set of amenities that lower floor tenants can occupy and utilize. So for the office experience, one example would be on the third floor, we have an outdoor terrace that the third floor tenant can occupy, along with a large green wall as part of that space. So it provides opportunities for both groups. And on the retail side, we're looking at how do we have an adaptable facade so that different tenants can interact with both their interior space and the exterior space, and that's part of a COVID response. And this just goes into a little bit about the process that I was talking about a little bit earlier. So we started off an ideation process where we're trying to figure out what are the goals of building. So the customized flexibility, integrated technology, and sustainability and well-being was part of that process. Then we moved into a separate exercise with several interiors groups where we designed the building from the inside out and trying to find the ideal floor plate that we would design for the building. And that was handed off to KPF and several other groups for what we call the RFP, RFC process, request for collaboration. And basically what that is a competition in which we work almost hand in hand. There's a back and forth dialogue. It's not just a design that's thrown over the line and then we just say yay or nay. No, we work through the process, and Amanda's going to talk about that as she goes through. And last thing is flexibility in design. Flexibility I think is a dirty word in construction. The idea that you change midstream can invoke these fears about change orders and cost increases, but there's a reason for it. And really it's how do we make sure that the space is adaptable for whoever our tenants are, either that be retail or office. And we're dealing with mostly law firms in this building, and we're at a point in time where office space is not as defined as it used to be. So an office, law firm right now might have issues with office spaces, open plan, and all those interact differently with the facade.
All right, thanks, Kahlil. So going into talking about flexibility and designing from the inside out, as we approach this project as part of the RFC process, we considered what the traditional typical DC office building is, building out all the way to the lot line. And it actually ends up with a large amount of hard to lease space at the inside of that floor, very dark. And so conceptualize the project in idealized components. What is the ideal lease space and how can we rearrange it to take advantage and really create extremely high quality space instead of packing out the block? And that resulted considering a double bar building with 45 and lease steps. Okay, apparently my ears aren't the right shape, so, okay. So how do we arrange these into a double bar building? And we look to insert courtyards, adding natural light on both sides of the building, and this was both to address the muffin top effect that Kahlil was talking to earlier, so we can bring in a courtyard along the party line wall, and also create a much more dynamic approach down the street, kind of breaking down the sort of monotony and the lot line effect along the buildings, which I think you'll see as we go through some of the renderings and in-progress construction photos. In addition to this, and bringing in natural light and creating well-being and high-quality space, shaping the building like this, including this inflection point along M Street, allowed us to create nearly 150 foot of additional perimeter office windows. And when you're approaching the DC leasing market and considering perimeter offices for law firms, that was a really important and I think successful approach to the building. Here you can see our typical floor plates, which are 50 feet and 45 feet. They allow for both double perimeter offices as well as a flexible layout for open space offices. We worked closely with our partner Arup in this project to create a clear span space that has minimal columns. You can also see, back to the muffin top effect again, where we worked through this idea of bringing courtyards to both sides of the building in this sort of K shape to make sure that there was natural light that came down to nearly every floor and created optimal lease steps around the entire perimeter of the building. You can see typical floor here as well as how the two courtyards flank the building in the 45 and 50 foot bars. Going through here, you can see the sort of inflection along the street and how we've created, you can see on the far side, how that courtyard space that Kahlil was talking about comes all the way through the building on M Street. And we've worked to really create a sort of warmth along the street where we've inflected in and created additional space in the public realm. And that includes having this cedar planking along some of the retail storefront, and we've used a large amount of natural materials, including oak, granite, and limestone to really create that warmth and craft along the street, especially as we're kind of creating this dynamic form that comes in and out. Playing into that, I think that the strategic planning of the building was really important and giving us flexibility to approach a wide variety of facade types. And I'm going to dive into that more as we get into the presentation and how we were able to flex them and allow them to wrapping that strategic form to help us control cost. We have two primary curtain wall types, which are wall type A and wall type C. You can see here. Wall type B is a thin set brick on precast, which lines the alleyway. It's actually really beautiful. Suggest you take a tour of the alleyway if you ever stop by 1700 M. I actually quite like it. And then wall type D and wall type E are our storefront facades. Wall type D is which you can see in our VMU here is wrapped with the cedar planking that we're working with Reson on. And we'll also have a wall type E, which wraps around the penthouse and has beautiful views out to the skyline of DC. But today I'm really going to talk more about wall type A, which is our primary wall type for the project. Like I said, because we're designing from the inside out, and we all know that we started the project in 2019. A couple months into the project, we all went home thinking we'd be back in a couple of weeks, and we did not. And I think that the careful planning meant that as costs escalated and then there was a lot of uncertainty in the way that pricing was coming back, we were able to approach the facade in a very flexible way because the planning was already so strong and provided this chassis that we could approach in a variety of ways. You can see the original wall type A here had a double cantilevered glass unit that had both reveals horizontally and vertically. You can see in a little more detail here where the glass came down, I believe about 18 inches overlap and had horizontal fins. But as we went further into the project, we realized that we needed to provide a more cost-effective facade, no surprise. And we worked through probably 30, 40 different iterations, understanding both unit size. We looked at both 10 and 5 foot units. We worked with a variety of fin depths, 18-inch, 16-inch, 12-inch fins, and worked with Harman, our design assist, to understand manufacturer limits on that. Ultimately, we went more from an 18-inch fin down to a 6-inch fin, which worked with typical profiles. But you can see that we actually considered a wide range of options, all the way from our double cantilever to a single reveal, horizontal expression, vertical expression, and I think that the design and the basis of the project shows that no matter what we coded the building in, the form and the design thinking and the inside-out approach meant that we could successfully build the project at a reasonable cost. Ultimately, we worked with Harman to select chassis 4, which is a 6-inch fin with some amount of vertical and horizontal articulation. And to help us evaluate these different VE options, of which there were very many, we kind of backed that up with some analysis, and that includes performance, where we evaluated the energy savings and performance of the fins, as well as different unit sizes, 10-foot and 5-foot unit sizes. We've actually been finding on a lot of our projects recently that sometimes the 10-foot module or even larger provides better energy performance savings. It was also very important, given Skanska's design approach, that we consider the interior experience of the building, and we analyzed a variety of sill heights, energy performance related to those sills and different units from inside as well. Ultimately, we worked very closely with Harman on a wide variety of costing, which we all know is very important, and that we worked with them to understand the varieties of wall type A and C and other wall types, but also how we could variously wrap the building in the extents. And ultimately, we worked with Harman to increase the amount of wall type C, which are our flatter and more cost-effective system, and decrease the amount of wall type A, but still effectively wrap the building. Here you can see our glass selection mock-up. We reviewed a variety of glass types, both from Interpane and Viricon. Ultimately, and surprisingly, this project, Interpane was both preferred option aesthetically, but also the cheaper option, even though it is shipped from Germany. It did take some additional considerations in terms of shipping times for the project, but we worked early to address those. Here you can see our wall type A shape approval drawing variation, but I got the year wrong on the presentation because they're from 2020, but from when we started in March of 2020 to the end of June in 2020, where we walked through those wide variety of VE options, you can see the cantilevered glass system, which was much higher cost, down to where we are today, but I think it's still a really effective system and speaks to the design of the building that we started with in concept. And now Kahlil is going to talk a little bit about some of the requests for flexibility, again, that came up during COVID in the project, and I think are really interesting in talking about how to address buildings post-COVID and moving forward. Is he good to go?
I'm good. So I think one of the things, like I said, previous architect, you always wonder, why are people making these changes? I already drew this. It should be set in stone, ready to go. Once switching sides, you kind of realize there's a lot of factors that go into why changes are made. And one of the things that's really nice about this building is we were able to do that relatively easily. When you talk to a lot of the tenants throughout the process, there are a number of comments, new ideas, different scenarios that you didn't think of that you're like, oh wow, that'd be something that'd be nice to incorporate. And so we have to evaluate, like Amanda said earlier, cost, performance, and experience to find a balance and create these changes. So I have two instances here that happen midstream. One is the retail level, which is on the ground floor that surrounds the entirety of our building. One of the aspects that we kind of discovered is that we need to be able to change the facade as a new retail tenant comes in, depending on what their needs are, if they need to be primarily interior focused, exterior focused, if they're a large retail tenant or a small retail tenant. So along the entire facade, this is not working. We had to make changes, and so we decided that for our spaces, we need to be able to subdivide these spaces and make sure that if we make a change, we do not impact tenants on upper floors. So if you look at this picture, towards the center notch of the building, and to the right, you can kind of see these new options, and they're not actually a day one experience. So what we had to do was split the curtain wall into two levels so that we were able to remove it so that we would not impact office tenants on the second floor. To the right is a bar area that we added for the penthouse space, so it's a amenity for the entire building. And the idea here was to provide not only flexibility for event types, but it's also to add a hospitality feel and something that differentiates us from other office buildings. So we were able to, through the modules of the curtain wall system in the penthouse, remove some panels and work with Harman, USB, and KPF to design this little bar area. So hopefully when the building opens, you guys can come and have a little after party with us. So that is and this is the current image of our building. So we are topped out and almost fully enclosed. We're currently working on the curtain wall on the first floor, and we're going to wrap our way around to M Street. And so hopefully within the next month, you'll see, basically a almost finished building, and then we'll be working on the wooden frames that you've seen in some of the renderings. And that's it.
Thank you.
All right, thank you guys. I really appreciate that. Again, thanks for the flexibility on the tech. It's a problem, I know. And so we got a little bit of time while they're setting up so that these guys don't have to stand the entire time that they're doing the panel. But I do want to introduce you to one person. Christian, if you don't mind coming in. So Christian and I are pretty good friends, and my girlfriend was supposed to be here presenting alongside of me, but our kid decided to get sick, so that kind of ruined that. So I'm just going to take one quick selfie with all of you, if you don't mind just smiling a little bit, so that she knows that I'm actually doing my job here. All right, you should hold this.
Okay, yeah, I can do that.
Yeah. Sorry, are we wasting? There's still, we have to do this. They get those guys.
All right, everyone smile.
Yeah, can you guys just move over this way a little bit? I'm kidding.
That's awesome.
Yeah, so Christian, you want to give us a little bit about what the panel will be?
Yeah, sure. Yeah. So hey everybody, my name is Christian Bailey. I'm a director at Morris Adjemy, MA in New York City. And so today's discussion panel is going to be at the Wharf, particularly phase 2, which is just a 10-minute walk down the street here. It's a great thing to do during lunch or after this, but it's a huge complex development over 2 phases, 10 years. The owners here, they'll talk about the collaborative effort, their vision. So we're kind of excited to present kind of the overall vision of the Wharf, and then we'll go through the 4 or 5 different buildings. There was Vignoli, Shop, ODA, where I was a founding principal there before going to MA, and then MA's project at Parcel 10. So it'll be kind of fun, and I think we have a variety of people from Thornton Tomasetti talk about facades, Jonathan Morley talk about the rails from Synergy, Christopher from Donahoe, the contractor, and then Martina, who's the VP of design for Hoffman. So good. All right, so I think we're almost there. So
Just 10 more minutes.
okay, just make something up. Okay, great. Come on up, guys. And how do we work the slides? Is it just say next kind of stuff? Okay.
Try to click it first, and then when it doesn't work, say next.
No, go ahead, Martina. You can get there and just fill in. Oops, sorry. Okay, good. Okay, so I gave a little bit of an introduction, but I'll let the panel introduce themselves, who they are, what they've been working on, and then we can start with the overall vision. Martina will tell us about that. So Martina?
Yeah, good morning, everyone. My name is Martina Schneller. I work for Hoffman & Associates. We are the owner-developer of the Wharf, along with our joint venture partner, Madison Marquette. You may have heard HMW, that's the Hoffman-Madison Waterfront Group, which was responsible for the development of the Wharf. My particular role was to corral all of the design and engineering teams, of which there were over a dozen architects on phase 2. So it was never a dull moment.
Right, a lot of collaborating.
All
positive.
A lot of visions, sometimes conflicting.
Great. Jack?
Hi, I'm Jack Solinsky. I'm a project manager with Raphael Vignoli Architects. So I was the manager for Amaris, which is also the 9th parcel on phase 1 and phase 2. And Martina, I manage 14 consulting firms on Amaris. So I think you should add all the sub-consultants to your list of.
Yeah. It would grow immensely.
Yeah.
Hi, everyone. Lissa Wong with Thornton Tomasetti, an associate principal with our facade engineering practice. Basically, TT was involved with Morris Adjemy's team on the Parcel 9 at 610 Water, and our scope there was doing envelope consulting, and I think collaboration is a great word, because I think it does take a village, as they say.
Good afternoon. Jonathan Morley with Synergy. Synergy is a design-led fabricator, installer of guard railings, windscreens, and feature stairs. On a typical year, we would do several miles of guardrails and over 200 feature stairs. On this project, we completed the exterior guardrails on the Amaris project, but also on the Pendry and Tides projects as well.
Hi, my name is Christopher Feely. I'm the quality control manager for Donahoe Construction, and we were the general contractor for both Wharf 8 and Wharf 9. And basically, we're a little different than other GCs. As a QC, we're just focused on the whole building enclosure system and just working to help coordinate with all the design team and subcontractors.
Great, thanks, guys. Martina, I'll start with you. She was here pretty much from the beginning. I think she was even master planning it at a different office.
Yes, back when I used to practice architecture.
Right, right. What happened?
Ooh, that's a story for another day, folks.
But okay, so why don't you tell us about the overarching vision of the community and everything?
So when the Wharf started, this is kind of looking at phase 2 on the screen. We started planning this in late 2016, before even phase 1 had opened. So when we talk about lessons learned, we were really going off of our gut for the planning. We wanted to make sure that there were a lot of public spaces and open spaces, and really being able to activate the overall community in the similar way that phase 1 was programmed. But in doing that, we took a really big departure in our architectural style. We wanted phase 2 to be really bold and to really take advantage of our last piece of waterfront that we had.
Right. And you can see on the slide, there's the phase 2 on the right, and then phase 1 to the left, which was, what year was?
Phase 1 was completed in October of 2017.
Right.
Yeah.
Right. And then tell us some about like the sustainability aspects of it and some of the goals and everything you had.
Yeah, so as you can imagine, you know, there were over 1,000 meetings with the neighborhood and the different components of everyone who wanted their voice heard for the neighborhood. Arena Stage is featured on this screen.
Right.
They had very strong feelings about maintaining their view to the waterfront. If you walk down there now, you can see that there's actually a park in front of them. And so the phasing and the strategy of that was really ensuring that we were respecting our neighbors and what they had, and didn't want to completely block out the sun and, you know, the views that they had been utilizing for the history. And so all of this kind of rolled together into our environmental and sustainable mission as we went through the process. So over the 27 acres, we have 10 acres of parkland. We actually have a natural bioretention area that filters the water, as well as capturing nearly 90% of our stormwater runoff, which goes through a cistern filtration system, which gets utilized in all of our cooling towers, and also extra irrigation for our green roofs. Every building has either a green roof or also photovoltaic systems. We also have a cogen plant, which we partnered with Washington Gas on, which utilizes obviously natural gas from the city, but also we capture the excess heat there to help supply our other mechanical systems. When the cogen is running, it can fully power our garage electrical needs. So there's no additional load that goes onto the electrical grid.
Great.
That's only some of it.
Yeah.
Should I keep going? Well, one of the other interesting things that I'll close out with is we also have floating wetlands. You can see them off of the recreation pier in phase 1. The DEC was really concerned about how we were affecting the integration with the waterfront. I mean, perhaps they preferred the old wasteland that was there.
Right.
But the wetlands were one of the ways that we really got them over the hurdle that we were going to be respecting the waterfront as we moved through this development.
Right. And then it was a community lead.
Oh yeah. So the whole development is neighborhood development. We have a gold for the entire project. The individual parcels are all silver rated, except for parcel 10, which is pursuing a platinum rating.
Right. Right. And then we could talk about, we'll talk about like when you started phase 2, the collaboration, like what was the idea behind the selection of the architects? Like how did you guys think about that, you know, from phase 1 to this? Was there a strategy there?
Bold is the word of the day for the selections. Our partners at Madison Marquette wanted to use a firm out of Paris, which I thought was going to be a train wreck. So we settled on New York for most of our teams. Perkins Eastman out of DC continued with the master planning because we wanted phase 1 and phase 2 to be cohesive along the ground plane and not look like we had just plopped down another string of buildings.
Right.
But we ended up choosing shop architects for our office towers, which are parcels 6 and 7, which you can see on the building there. The next one over is parcel 8, ODA. This guy had something to do with us selecting that team.
Right, thanks. One of my favorites, but now I have other favorites.
I was going to say, as we move down the list, you may shift your attention somewhere else. Parcel 9 is Raphael Vignoli, Jack's team on that one. We really wanted our condo building to be iconic on the waterfront. I think we achieved that through the process. And then parcel 10, it was Morris Adjemi. They have done other things in DC, so they were a really easy decision for us to come back to the waterfront for this really boutique office building that is the end cap for the Wharf.
Great. So now we can now we got the overview, which thank you for doing. We'll go into individual projects, talk about the design, talk about some of the technical details, some of the challenges, lessons learned. And Jack, why don't we start with you with
yeah, so thanks, Martina. So as you mentioned, Morris is the is sort of the luxury condo building component of phase 2. And and plan, it actually sort of forms a bookend to the parcels running along Wharf and Main Avenue, and facing. It's actually I think it's the one building that actually doesn't face the water in a way, facing parcel 10 and the park, and between those buildings and Arena Stage forms a sort of kind of public square in front of it that also serves as a focal point when people are approaching the district from the east. And so Martina and her team wanted bold, so we brought the bold, playing off of Arena Stage and the marina and the environment around it. It was always very important in every iteration of this project that it sort of follow this organic form and have a real sense of movement to it.
It's interesting, the sketch sort of looks like the final thing, right? I guess that's what the idea, right?
To be fair, this is a later sketch.
Okay, you didn't have to say that, but yeah.
It has
this wasn't some napkin sketch at the office.
So in early, from early on in the project, the really key design principles, like Martina was mentioning earlier, were maintaining a visual connection between Arena Stage and the water, which I think is a very common or a very persistent theme in a lot of projects that our office does. Oh, there you go. Of trying to think of projects not just as for their client, but also how they impact their community. And so being respectful of that institution and maintaining its views to the water and its connection to the water. Oh, sorry, if you could stay on that slide for a second.
I was going to say, you may notice that the original building had quite a tilt to it.
Yes, it had a bit of a tilt to it, which also, one of the other really important things about it was to enhance the park in front of it by curving away from it and also at that time sloping away from it, but basically sort of receding from the park in a way that let it feel open and expansive. And even in the reflection of, like, say, the guardrail system, creating a reflection of the sky that makes it feel, very bright and open.
My team was more focused on the building not tipping over.
Right.
So we then convinced ODA to step their building back so that we would open up more views to the water.
Right. That's part of the collaboration, right?
Yeah, there you go.
Yeah. I mean, we get... Right.
And so as we developed the project, obviously working with a curved building with curved facades, our office has had a number of projects in the past where we've worked with both buildings that utilize cold form curved facades as well as I guess you would call it like, I don't know, hot bent curved facades. I'm sure there are many people in this audience who could explain the difference between those better than I could, but it basically, when dealing with curved wall systems or glass, you can either fabricate it in the factory in a curved fashion, so it is permanently deformed and it shows up in that way, or you can manufacture it as flat components that you bend into their final position. And if you were to uninstall them, they would return to their flat, configuration. So, factory form curved elements are rather expensive to make every iteration of. So it's ideal to, optimize your design to utilize those when you have a lot of repetition, a lot of scale. Whereas cold bending is conducive to situations where you can't have a lot of repetition. So, that is essentially what we did. We ended up with a mass in the end, which is effectively a cylindrical surface on the front and back elevation of the building, and then a very steeply sloped, actually 24 to 25 degrees. It varies from panel to panel. Double curved curtain wall in the north and south ends.
Right.
And then this is the final massing, and although it doesn't lean, I think it still evokes a very strong sort of organic form to it, and then also is sort of like receding from the park and having this sense of movement that was always the driving intention of it.
Right, and especially if you're driving from the south. I mean, this is kind of the key piece.
Yeah.
And it works well with the arena stage too.
Yeah. And then, so for the curtain wall system, basically this is the cold bend system, and every panel on either facade is a unique trapezoidal shape. So there's 280 curtain wall panels total, and there's 140 unique shapes. And then each one is about 4 feet by 12 feet with an out of plane deformation of about 1 inch to 1.5 inches. And one somewhat unique thing about this system is that, as opposed to a conventional curtain wall system that uses the chicken head to sort of lock one unit to another, this system uses what they called a spigot, but is basically a knife plate in the vertical mullion that engages from one floor to the next.
Great. And Christopher, do you want to add to this about the construction aspects? And
actually a few of the refs and installer that did this project, and I think one of the biggest challenges is just the geometry. There was so much layout and verification of dimensions, constantly checking through all this stuff. The amount of meetings, constant weekly calls going through with the subcontractor, with Jack's team. It was challenging, especially at the interface corners. This system was difficult as just one. We thought this would be the most challenging part, and it ended up being kind of the easiest part. The window wall system ended up being the hardest part to deal with, and then with these two interface, that was a challenging detail, interfacing different membranes, with self-adhered membrane with a silicone boot. We had structural components that were in and out of the slab. The corner panel conditions, they were scanned. Each piece, kind of like the windows, were individual custom piece throughout all the corners of the building.
and did you guys do like a design assist during DDs or CDs during the drawing process to
we did
some of this?
Design assist phase in the only way that I've ever experienced it, which is significantly after finishing construction documents.
Oh yeah,
just
sounds
a suboptimal situation. But yeah, we went through I think about a 12-week phase of just going through the preliminary design, detailed concepts and assumptions and all that before going into shop drawings. So Not the planned design assist process, but a design assist process.
That's and did you have the metro underneath your building directly at all to deal with?
Yeah, we did, and
fun.
Yeah, we were the ones who brought that up. That maybe we should
yeah.
Well, I mean, I guess it's not part of the talking points, but it is an interesting issue that so since the metro line went under our building, that we did a number of acoustic tests were done to see whether it would be perceptible, and we found that it would be. And the form of the building made isolation kind of challenging because the building basically wants to tip over if it was not held down to the ground. Its form is eccentric in a way that that some of the shear walls and columns are actually in tension, which meant that the isolation had to occur underneath the garage. We looked at ways to do isolation, say at the ground plane between the garage and the building, or between first floor and second floor. But because some of the elements were in tension, it wasn't really feasible. It all had to be down below the lowest level of the garage.
Right.
So the whole thing kind of sits on a mattress in a way.
Nice. And maybe we could talk now about Jonathan, the handrails, because those were kind of unique, custom, and well thought out too. So maybe about that process.
Absolutely. Yes, as you can see on the building, the guardrails are a huge part of the aesthetic. And we were brought on fairly early in the process because of that, using a design assist process to collaborate between ourselves, Hoffman Associates, Raphael Biloni Architects, and Donahoe Construction. A couple of the challenges that we faced here was the initial design intent, which was to have curved guardrails, curving not just in the y-axis but also in the x-axis and covering the slab edge. There were also other market-based challenges at the same time, supply chain volatility, logistics as well. Installing almost 6,000 linear feet of guardrail on the edge has had its own challenges. And we also had some budget parameters that we needed to adhere to as well. We had a very collaborative process, and through it we were able to dig into the code, find some opportunities where we could use monolithic glass in lieu of laminated glass. We're also able to use sensitivity analysis to look at the connections to the guardrail, look at the stresses from wind loading, and optimize the thickness of the glass as well. Through the design, we made it very repetitive, and we added in tolerances to cover all construction issues, but also to make sure that we could easily and quickly install it, which was a huge cost saver and allowed us to adhere to the budget. Also, it allowed us to do a little bit of experimentation, because I hadn't heard of cold formed glass up until this point, and Jack brought it up. So we had the time, and we put together a mock-up in our shop. We tested it held up. Unfortunately, we couldn't get comfortable with it for a life safety product like a guardrail, but it was great to have the time to experiment and push boundaries.
Is that your SketchUp there?
I can't claim that. No.
That's great. It looks very architectural.
Yes, we.
That's how you start your process, with figuring things out with the sketch and then taking it into.
Yes. Sometimes whatever medium kind of works with us in the design team. This project we use 3D models a lot to communicate, to make sure that we weren't missing anything in communication. But sketches and renderings are always key to make sure that we're all reading from the same page.
Right. And then Christopher, what were with this handrail, like what were some of the differences between, and challenges between this handrail and then y'all also installed on parcel 8 too? There had some different challenges there, right?
Yeah, that's a good comparison. And what this one here, the design gives a lot of flexibility. It doesn't seem like it's all well in beds. But initially when we first started, we had issues with reinforcing the slabs where we couldn't get the inlets in. We basically had to place Nelson studs, and we had 2 inlet conditions that, there were some conditions we weren't sure where they were going to occur at throughout the whole facade. So we basically have a shop drawing with 2 different conditions with a inlet plate with the Nelson stud, and one we did the box out with a tube steel, as you see right here. The inlet plates here, and then styrofoam with the box out, where there was too much reinforcing them. And then with the steel posts that we were able to get precise dimensions across the whole elevation, included with the variations of the slab thickness or any variations of concrete slab tolerances. So they kind of cut those pieces to precise elevations so you can see these clean lines across there. The Wharf 8, we actually had quite a few issues where it was more the shop drawing phase. We had waterfall condition issues, and those are all base plate mounted type systems, and we went through a lot of iterations, a lot of collaboration with the waterproofer, the installer, the design teams.
Right.
And it's, I think, we keep on that collaboration, and that's how we resolve a lot of these issues. Early on in the design phase, initial install, during shop drawing phases, working with the sub, design team, really keep things going and make the process successful.
I mean, Jonathan, on parcel 8, I thought you were going to give us like an off-the-shelf kind of system. It shouldn't have been that difficult, right?
The difference between the 2 projects was on parcel 9, we were in a design assist.
Right.
Design assist process with weekly meetings, collaboration goals, and on parcel 8 it was more the design bid build.
Right.
Working through value engineering, and both very collaborative.
But kind of a lesson learned, the design assist actually, you saw the benefits of it, right? So, great. So here's the finished product.
Yeah.
Oh, yeah.
I'm not so sure I would call it a diving board. Yeah, I mean, I don't think there's another balcony
quite like
experience like this elsewhere in DC, and or probably in the United, maybe not too many in the United States. And just to be a unsolicited marketing ambassador for Synergy, for a moment, the earlier images of like the 3D model and obviously the sketch, they came to every meeting with us with that kind of content. We never were sort of for lacking a visual explanation of what they wanted to do. And that was a great experience. Like every week we were sending back Rhino models or 3D CAD models or whatever, which is, I think, a very, it's really the ideal way to be working through these kinds of things.
Right.
So, and then this is just a view from that's from the golf course. And then the next one, that's from the roof of Parcel 10, the Morris Adjemi building.
Right. And so this was finished in, when was it 2 years ago now? Last year. Right. And so people are moving in now?
Yeah, over 60 people have moved in at this
Wow. That's great.
And then this is a view from Main Avenue, from the park. And I think, this sort of shows the predominant sort of feeling from this perspective is the sky and the park and everything. It doesn't feel like you're being beared down upon by some building, which is, I think is great. And then this is from over at Arena Stage. And so this is the 6th floor amenity terrace. which is, I mean, turned out to be, not that I expected it to be bad, but it was a surprisingly, anytime I was doing a site visit or something, even if there was nothing to look at up here, that concern, that I needed to look at, I always came up here to take the same photos over and over and over again. It was one of my favorite places to experience the building. And I think this really shows the benefit of the sort of, parallel design paths between, our firm and your firm at the time, where, we sort of helped out the park, and then you guys helped out us. The terrace is benefits a lot from the way that Parcel 8 steps back and sort of opens up the sky to the terrace.
Yeah, and this might be a good transition to Parcel 8, which is the building on the right side, and that's like in this, like you were saying, Jack, like there's a communication between the two. Not only does a stepping back benefit you guys, but it's residential, so we wanted to create these step back terraces for the residences that also let light into the courtyard. So it was, it worked site-wise and context-wise as well. So just a brief, overview of Parcel 8. This is ODA, and I think when we started, we met with Martina, and you told us a couple ground rules, like you're done with the nautical themes. Yep. Don't bring any of that stuff. Let's keep it fresh and modern. So it was a good approach. We had kind of a C-shaped building, and one of our, the design approach was from the upper left. We had the benefit of this pocket park on the left-hand side. Paul Josie was the landscape architect, and that just started it as a unique shape. And what we did was, on the middle slide up, was we took the first step of stepping back, creating terraces with the views of the water that let light into the courtyard, and it opened up views for Parcel 9 as well, looking towards the west. And then on the lower left-hand side, that area that we carved out for the stepping, we added it to cantilever, and that is the hotel side. So it's a mixed use. There's hotel on the left, residential on the right. There's a school on the ground floor, and retail on North Avenue. So it's because of the mixed use, it also created unique opportunities for design and addressing the site. And then by the the middle slide on the lower on the lower part of the slides, that pink, that's now the Pendry Hotel, which is amazing place. And that had its challenges too, because we're stepping. You'll see maybe we sawtooth a little bit. So every room was kind of unique, but it's also strategic because we're 30 feet from an office building, which is shop. So the sawtoothing was designed so that rooms faced the water, and then it wasn't an immediate looking into the hotel rooms, which I think worked. I mean, I think Donna, you maybe had one or two design or construction challenges, but I think we got through it.
Again, like Parcel 9, we thought the sawtooth was going to be really challenging. That turned out being one of the easiest.
Let me see if I can get to that.
Yeah, that's a great one. It's just the whole process of the sequence. And the system here, we basically had a primary air barrier system with an overlay on top of insulation and plywood base, or nail base with a metal panel. And we had 4 different contractors involved in this detail. We had 2 different contractors doing the membranes. And early collaboration, we worked out to just basically strip in. Luckily, we had curves continuous around this whole sawtooth. So we stripped in a secondary layer so that once all the framing, insulation, nail board went in, we were able to sequence everything in. I think one of the bigger challenges is access. You can see right here, we kind of engineered a cantilever scaffold so they could do it. It actually spans 2 floors.
Right.
So the first level there was, harness walk out, and then they built this scaffold system both sides and moved it up each floor as they progressed up.
Right.
But yeah, it was just, this went flawless, and
It's amazing.
really worked out well.
And you can see this view is actually from the residential side on the other side of the courtyard. So you're not looking into the hotel units. The windows are on the other side of the sawtooth. So that was part of it. And then Shop's building was so reflective. Even if you're in a back seat, you can see ripple effects of the water through their glass and everything. So
That's one of the really interesting parts about the phase 2 is there's so much glass on there. Sunsets and water reflections just start to appear at all times throughout the day. So even if you're a block off the water, there's a good chance that you're getting a water view.
right. And so you can see on the right side the stepping, and you know, like all projects, we went through our set of value engineering, and you know, middle of the way we had some collaborations with the owner. The stepping had to be, I think we had 12-foot stepping on the left-hand side, and that obviously created some issues with, well, no issues with us, but I guess with you guys, we liked it. But it was easier to construct and coordinate some of the offsetting and efficiency of the more FAR, or not a more FAR, but just.
We were just looking for some more gross square footage, because what Christian has buried the lead on is that 50% of the apartments in parcel 8 are affordable. So we range the affordability all the way down from 30% AMI up to 120%. Right. So we really hit the cross section of everyone who needs an apartment.
Right. So that's kind of an overview of that. And it's really interesting because that pocket park, we took that on the lower left and then kind of, you know, imagine it going up the building and around and then ending at the rooftop at the pantry. So, I mean, it's open. I mean, it's a great, you guys go down there, you can go to the rooftop, it's open. It's really fantastic views and everything. But it is, because of the complexity of the building and the mixed use, it kind of created this unique design, I think. And part of the collaborative process was to, not only with the city, with the owner, with each of the architects, we went through the Commission of Fine Arts because we have federal land at Haynes Point. So there's a whole series of meetings and then the other thing with the collaborative process with Jack and us with Vignoli and Shop and with Morris Adjmi was the owner would set up meetings in New York at different offices, and we would share where we are with the design approach and collaboration, and then that's where kind of the dialogue, you know, was happening. So kind of a unique approach. I mean, architects don't always, I mean, we like to get along, but sometimes, so. And then I'll speak a little bit about this project. This was before my time at Morris Adjmi, but, and help me out but it was kind of the southern anchor of the development. The idea was kind of this floating jewel box. And this again was, I think this went to LEED Platinum because the Atlantic headquarters is there, and that kind of led that kind of.
The Atlantic, we knew they were interested in a smaller office space and wanted something really unique to the city. So we made a connection with them. And before we had even started construction, we were still digging the hole. They purchased the office building from us based off of 2 renderings. So it was really a leap of faith between our team and theirs to make sure that we were going to hit their design vision as we worked with Morris Adjmi's team to work through this. So as Christian mentioned, the jewel box is rotated, which created a lot of beautiful cantilevers and also an enormous second floor terrace, which the Atlantic hopes to program for additional activation of their retail space. This shows it really well. So there's meditation garden up on the eastern edge, which is off screen now. We're looking towards the west. They have meditation gardens, there's plantings. It's all integrated into their holistic ESG platform. So they really intend to utilize the inside and the outside of this and activate on their terrace and then down into the Plaza Park as well.
Right, and I remember in concept, there's also like some kind of stage or stairs. Well, where did that go?
Well, you see some of it is reminiscent in the landscape still. There's borders that create the two swooping areas where the pathway goes through. So those are actually set up as seat height walls. So the idea would be that the crowd could sit there and then you could bring out a platform in front of parcel 10 and have a concert. It was really meant to be the outdoor amphitheater to anchor the end of the promenade from phase 1, because you get a direct view line down the whole street-lined promenade.
Great. Well, thanks. And then with Morris Adjemi, we worked alongside with Thornton Tomasetti and Melissa on the facade and the waterproofing. And you want to talk about those?
Yeah, thanks, Christian. So we'll run through this quickly since we're standing between you guys and lunch. As they mentioned, the project is a LEED Platinum project, so we did have to up the performance on the facade quite a bit. Most of the glazing used on the project were triple IGUs with a high performing coating and argon fill. The main, the main portion of the building of the jewel box is a unitized curtain wall that really utilized, floor to ceiling glazing. It wanted to have this very continuous glazed appearance. So what we did was really hide the anchor of that curtain wall within the face of slab, which, as you know, typically does require a bit more of a slab gap in order to provide the tolerance and access for the installation. Here we had a 4.5-inch gap with about 1.25 inch in and out tolerance. And the other aspect was, to enhance the thermal performance. We really didn't want to thermally break the layer of glass with an intermediate frame, which typically does deplete your thermal performance a bit. So here we're using a zero spandrel detail, which goes with a continuous layer of the thermal boundary, but also allows that very continuous aesthetic of the glazing system. Here's just a couple of details. One is showing, as we talked about this rotating jewel box, it does create certain interesting angles at the corners. And so there were a few different corner conditions where specific dies and extrusions were made for those split mullions. And the glass at that corner was also offset on the outer light in order to provide that closure of the split mullion joint, so you see the same thin joint as you typically do on the flat wall area. The other detail on the left is showing the end condition as this curtain wall transitioned to a soffit cladding, and capping off that curtain wall system with a continuous layer of thermal insulation, and being able to tie in that bottom of the curtain wall back to the bottom of the slab where our air vapor barrier for the cladding system exists, as well as the insulation line. So we want to make sure it's as continuous as possible. And just some, no worries. Some interesting images during the construction. On the left, you could kind of see that zero sightline spandrel pretty evident. It's a very thin reveal sort of behind the glass, but most of it you do see the glazing pretty much for the entire box on those two floors. Another interesting view at the rooftop is, the rotated version of that, I call it bulkhead, but it's really the top floor above that main roof surface. And here, as we're talking, about these rotating boxes and these juxtapositions of spaces, it really starts to create interfaces that become very interesting transitions. Here we're looking at the second floor roof, where the roof itself, spans from a large area, as you saw in the image before, to a very thin, slim space here on the left photo. So some of those transitions between the roofing system and that base of the curtain wall were also challenging, as well as that transition at the top of this curtain wall at the second floor to a soffit, to a unitized system. So there are multiple different players and systems all coming up at one area. And some of the challenges that we saw during construction, I think notably part of it was the different teams for the below grade and the parking structure versus the building. As you know, this master plan has a huge parking structure that runs below the sites. And that waterproofing was a different scope and was done by a different team. And so in order to figure out how to tie in that waterproofing to our facade base, there was quite a bit of coordination and detailing that went on in order to understand how their system came up and integrated with ours, and compatibility of materials. And these kind of shop drawing details were created. Thanks. And then, so I think part of, the coordination efforts is also sometimes they don't all get picked up at the first time. And so at the base of these precast columns, you could see the waterproofing came up, but then there are some areas where there needed to be some flashing comeback, because there were some areas that were missed. So you can see some of the concrete there at the base of that precast, which we picked up during some of our site visits. And so, through collaborations with the contractors, making sure that we come back and figure out how to tie that back into the precast base.
Great. And I might skip ahead to the end. We have 1 minute, maybe some closing comments from Martina on, how you measure success of the community. And let me just kind of bump up to that. Yeah.
So I think that, we were planning phase 2 before phase 1 opened, as I mentioned, and then phase 1 opened with such a bang, and it was so well received by the majority of the community that we're calling it a great success, and we're hoping for the same thing in phase 2. Most of the retail spaces are filling out, the apartments are renting, office space is doing relatively excellent compared to the remainder of the city. Williamson Connolly took an entire tower, parcel 6, and then we've found tenants that are interested in the remaining space in parcel 7 as well. And the parcel 9, the Amaris, the condo, as I mentioned earlier, is moving through sales and settlements. So we have people really activating and living on phase 2. We were joking that we were going to end with the Chihuahua races, because what's better than dogs running?
And you have a pretty active Mardi Gras too, right?
We do have a pretty active Mardi Gras. We have the District Wharf Community Association is based on site. They handle everything from security to programming to make sure that the community is staying really engaged with all of these events that are free and open to the public, so that there's something for everyone to do, whether you want a $4 falafel or you want to spend $400 at one of the new restaurants. So we're really trying to make sure that it's open and accessible for everyone, regardless of how much you want to spend.
Well, I want to thank you guys so much, all the insight and for your time and talent today. So thank you very much, guys. Thank you for listening, everybody. Thank you.
Thank you. Thank you all. I think a round of applause for our moderator, Christian. It was amazing. Thank you so much, Christian. Right, we're 10 minutes before schedule, so we'll take a 1-hour lunch break. We'll start at 12:50, and hope to see you all back. Session 3 is exciting. We've got some excellent talks, and I'm being told that the last panel discussion is as great as this. It's on sustainability, so please stay back for that, and hope to see you all in session 3 soon. Okay, I think we're good to go. So welcome back, everyone. So we have a second event host for the PM session. I'd like to introduce John Jackson. He's an associate principal with SGH. He's going to be hosting this session. So over to you, John.
Thank you very much. Nice to see everyone. Welcome back for the afternoon third session today. Hope everyone's had some food, some refreshment, lots of caffeine. So really have an exciting panel for the last session today. And so, yeah, without further ado, I think we can get started. Our first talk this afternoon will be Defying Gravity, How Architecture Fuels Innovation. The speakers are going to be Sean Lyons, Principal Senior Project Manager with Page, and Paul O'Connell, Principal and Senior Project Architect with Page. So with that, gentlemen, you're up.
Good afternoon. Real quick, make sure the show works. Oh, we were there before. There we go. All right, so real quickly today, what we're hoping to cover for you all is we want to talk about this really exciting project that Paul and I just finished for the University of Maryland. It's affectionately known as the Idea Factory. Just a quick introduction. My name is Sean Lyons. I've been with Page and practicing architect for over 35 years. I am the studio director for DC for the academic and housing studio for Page, and my colleague Paul.
Hi everyone, I'm Paul O'Connell. I'm a senior project architect, and I have pretty much in my entire career focused on academic work. So today we're going to be talking about some of the challenges and explorations of the design of the Idea Factory. We'll talk a little bit about the complexity and beauty of precast, how we used glazing in the project to really accentuate one of the core missions that we were given, which we'll talk about. We'll dive a little bit deeper into the dichroic glass, and then we will talk a little bit about just how the project came to life.
And the story I want to leave you with before we dive into it is that this was just to show the possibility of just using conventional building materials and some of the fun that you can have with it and what's possible. So I'm going to start talking about what most architects love doing most. Any explorers in the room? Anybody like to explore and see what's possible? So we took the design challenge, and first we started with what our project was. It's a mouthful in the world of acronyms. We broke it down to innovate, design, and engineer for America factory. You're like, what is that? Well, it's for the engineering school at University of Maryland, and it was a challenge to create this new building that brought together some new innovative ways of thinking and new approaches to engineering. So with that, we started looking and having some fun with just the words. What is idea? What is Idea Factory? That's what this project was affectionately known as. So start with idea. What's possible? You put a room full of architects together, you get the infinite ideas of what that could be. And then we looked at factory. We all have these old visions of what a factory was. But really, in today's world, what does the new factory for engineering start to look like? There are all kinds of exciting new things happening. Robotics that are influencing, biomedical work. And then just this place we discovered in Melbourne for the factory of the future, just a place that's a place like what we were trying to do here at Maryland, where we're bringing new ideas and new thoughts to what's possible here. And then just losing the latest from drone technologies and new technologies, virtual reality, things to see what is possible. So we put all of that and started stewing on that. We looked at project types that we had done in the past that had similar feels for that. We really wanted to focus in our buildings and bringing people together to foster collaboration, creating places that interact with the areas of research that are being done, and creating a visual focus for where all that can start to happen and people can gather together. And then, what are some of those places from research and that are done, and then the teaching that happens in those, and learning that happens in those spaces.
So before we jump into the building envelope, we wanted to talk very briefly about the planning of the project, because that really affected the ultimate design of the building. Like any project, we started with our main circulation. We had some initial ideas about program on one side of the circulation, core elements on the opposite side. Again, we looked at ways to break that down because we were dealing with a site that had multiple views on different sides. So we thought, well, maybe we'll push the program up against the edge of the glass so people outside could see it. and create some areas inside the building that responded to different areas of the site. Again, these are all just some different concepts that we had for laying out the building, views inside the building. Again, coming back to this precedent idea of a factory. What is it to be in a factory? Glazing was a big thing for us. We wanted to bring as much natural light into the building as possible into these public spaces. For those of you who are familiar with the University of Maryland College Park campus, the project is at the Kim School of Engineering. The little red box that just popped in is the location of the Idea Factory. It's immediately to the right of that red rectangle is a plaza. You'll see the 9 little squares that look like a phone. That is Kim Plaza. It's really the heart of the School of Engineering. And we wanted to play off of that and really activate that plaza. So we looked at putting all of the public spaces on the first 2 levels. This is something very important to the university. They don't see just the street level as a public space or a public level. They also see the second floor. Again, I'm going through these really quickly, but again, this is just all leading up to the ultimate form of the building. It was really to give views inside of the building on the public floors and be very efficient about providing spaces for the students inside the building. The arrows are pointing to the cafe, so we were looking at putting the cafe right along the plaza. And then again, this idea of views into the building and through the building from outside. This is a typical upper floor, and all the blue was originally conceived to be glass. So we were originally thinking of this project as being a glass box. But then we met with the donor.
So you can never leave a room of architects alone for too long, because your client will come back and challenge you. Anybody here like a challenge? So our client, when we met with him, Mr. E.A. Fernandez, said to us, I want the project to defy gravity. How cool is that? And the building should reach for the stars. We're like, okay, we're up for the challenge. So we started playing again with our diagrams, and we started elevating the parts of the building up, and then we created this little, on the second level, we moved the cafe up, and we put those startup and spit garage factory places where the activity of the building was on the first floor. But I said, okay, we got to explore this a little further and see how we can defy gravity with this. So we started playing with massing and modeling and come up with some really interesting ideas that we were excited to share. But we didn't want to forget the second part of that, and that was to reach for the stars. So we started looking at some ideas. So there was a couple of things that came from our kind of design charrettes, was this idea of lighting on the outside of the building and this sense of ascendancy as you arrive in the building. So we're thinking of all this, and we started putting it together. And this was how we responded when we came back. We created this elevated mass. And I don't know if any of you all know the campus at University of Maryland, but every building on there, the campus vernacular is brick. So introducing something that's precast and white and stands up is a radical idea for a number of people there. We elevated the mass of the building, and we kept all kind of glass curtain wall in those areas where all the excitement of the building was happening. And we were creating this, you'll see in a few other images, a stair that leads up to it, but we're also thinking about nighttime and how we could start to activate and make this place fun. We wanted a building that was as dynamic as the program was. So we introduced some elements. We introduced lighting on the outside in these little nooks of the precast. And we introduced something that Paul's going to tell you a lot more about, called using dichroic glass to really activate and animate the feature of the building. And this is the reality of where we ended up. It was a pretty exciting moment when we got to this. But now I want to talk about the kind of materiality of the building and what some of those challenges were. So I'm going to talk about precast. And For those of you who are architects, you'll know precast is a wonderful material to work with, but there's a lot that you need to think about when you're putting precast system together. So we started with our design ideas, and then we talked about the lighting and the windows that are integrated into that and this complex patterning, and you're like, how are we going to make this real, right? That's always where the fun of design happens, where the rubber hits the road. So we met with some precasters, and I don't know, anybody here ever drive a truck before? Because you got to know how big a precast panel will be. What's the largest size precast panel you can make that'll fit on a truck to get out to the job site? Well, I can tell you for those dimensions that are on there, 13 plus by 20 some feet, that's your limitations of what you can put on a truck. So we worked our patterning out, so we used the same module. So the precaster could use basically the same footprint of formwork. And then we created variation in the pattern reveals. And then on occasions when we would come to corners and things where the geometry didn't lay out perfectly, you'll see those gray tones. We didn't build that, but we also profiled it. So you'll see the panel to the left has a little chamfer on the edge. So how things transition is really important. And then, you know, the panel to the far right has a light insert to it. So we had to think of all these things in a panelized system and approach. We also had to think very carefully about the details. So those of you who design facades know that movement in a facade is really important to calculate and think about. So we got our sealant joints all figured out in size based on that panels at 3/4 inches. And then how do we integrate other reveals that we want? Because if anybody ever looked at a precast building, you'll know you don't want to see all those the sealant joints and reveals in different sizes. You want it to look clean and homogeneous. So we spent a lot of time to get that right. Talked about how to integrate lighting. How do you do that? So we worked out a light fixture that fit in there, and we cast the conduit into it, so it was actually easy to feed and service. But I had to think about all that integration up front in order to get it built. And this was actually built, it's a design build project, so this was an accelerated schedule as well. So the other parts of working with precast that are important are to make sure you do a mock-up, because no matter how well you draw it, the rubber hits the road when they make it. You know, you got to get the coloration and mix right, but the reveals how things start to come together. It gives you a chance to test it out. You need to be there on the job site when it starts going, so you could see that truck where everything came right off the sides and onto the crane. Contractor was super happy with this. This facade went up in a week and a half, every panel. And we were there to watch it because it's so important to make sure that the panels come together correctly. Anybody in construction knows that nothing comes out perfect. So what are your plans to deal with that? If you've got Mars on the building, like the image to the left, how do you clean that so it's not a problem? And the image to the right, what happens if you get a little chip in the installation process? Is there a plan to repair it? We had worked all that out ahead of time, so it was a seamless process. And in the end, we had this highly articulate facade that was really, really quite dynamic. But that was just part of the facade fun that we had.
So the other thing we did, again, all to support this concept of defying gravity, we looked to glass. I talked a little bit before in the planning part about how the university considers the street level as well as the level above the street level to be public, and they want to highlight that and make it as transparent as possible. So what we did to support this concept of defying gravity is the first 2 floors are glass. We did full height floor to underside of slab, clear glass. There's actually no spandrel glass on this. And what you're seeing in this photo here is actually the shades. And then the other feature, I talked a little bit about, we originally thought about this building as a glass box being like a lit beacon. Well, because we shifted gears after meeting with the donor, Mr. Fernandez, and we ended up with a precast mast that's floating, we still wanted to create that beacon, so we used dichroic glass, which I'll talk about in a minute. The other element to the floating that we wanted to accentuate was the terrace, the second level terrace. And we had considered taking glass all the way up and decided we really, after further study, we really liked this idea of a floating plane. So we introduced a short band of composite metal panel. And the other question I wanted to ask the crowd is I don't know if you worked on a building that has a strange geometry like this, but the terrace actually had to have lightning protection on it. So I don't know if anybody can see any lightning protection there. We actually came up with a very creative way and created small posts at the corner of the terrace that's projecting out from the precast and integrated that in with the glass rail. So it's invisible from the ground and it's virtually invisible from the actual terrace level, because lightning protection is not the most attractive feature of a building. And then this is just a detail how we, transition from the glass up, switch to metal panel and then reintroduced the glass. I'd also point out that we went with the glass guardrail for two reasons on the terrace. One, just to make it more transparent and open, but it also gives the illusion that the glass is going through or behind the metal panel, which accentuates that floating, defying gravity concept. This is actually a picture of the terrace, and I'm showing this for two reasons. One, if you look in the clicker is not working, there we go. If you look in this corner, there's actually a post built into the guardrail there, which is the lightning protection, pretty invisible. And the other thing about this building, there were a few discoveries, some unexpected things, one of which was a result of the dichroic glass. You'll see that green reflection. So let's talk about dichroic glass. The glass itself is not dichroic. It doesn't have any dichroic properties. There's actually a film that's sandwiched in between two thinner pieces of glass, and that makes up the outdoor light of the insulated glass unit. It ends up being a little bit thicker, which is why the overall IGU is 1 1/8 inches instead of just 1 inch. But the effect is pretty stunning. And why did we use the dichroic glass? Again, we wanted something dynamic. We wanted something that caught the eye. We wanted something colorful that had transparency. And this was kind of gave it that beacon, that lighthouse effect for the School of Engineering. And it faces their plaza, which is the gathering space. And then while I talk, I'm going to try it. So just in a matter of 30 seconds, walking around the building, you'll start to notice how the glass changes depending on where you're standing. It started with the deep blues and purples. It kind of gradually changes to aqua, shifts to the green range, ultimately ends up in yellow. But again, depending on the angle that you're standing, you can get a full range of colors as shown on the picture on the left. The other interesting property about dichroic glass is it also, what you see depends on the light source. So if you're standing on the side of the glass with the light source behind you, with this particular film, you see the greens, the blues, the yellows. At night, when the light source is behind, it's purple. You get the purples, the pinks, magenta, and a little bit of yellow. This happens to, I also wanted to point out, you can also see on this photo, the precast, the slot lights that Sean was talking about that were inset into the precast panels. This is a photo of the inside of the glass, and this was taken in the morning, I think around 10 a.m. On the eastern side of the building. So you get these very vibrant, beautiful colors. And then the last unexpected thing was, for about 2 minutes in the morning, every morning, the sun shines in and it just happens to hit the angle of the stair perfectly, and this stair feature that we purposely made white just glows with the color of the light.
So the best part after finishing this whole process is to watch your building come to life. We talked innovation was the key word when we started this, right? So we literally were able to watch students, and the building was finished literally right at the end of what we call the end of the pandemic. Watch students come back and start to infiltrate the building and take ownership of the building. And it's just magical to watch that innovation starting to happen. This is a space that we mentioned in the program. It's called a startup space. We call it engineers' version of Shark Tank. They are pitching their ideas and developing new entrepreneurial ideas, but they're also working with the business community who will back some of these ideas. And this space, this was taken on a Saturday night. And I don't know about you, but my memory of college is I was not in my building on a Saturday night. So that shows you how much life is starting to come alive in this building already. But it's fun to go back in the nooks of the building and see different areas of research. You can literally walk around and see all of this on display and see people engaged in discovering new and exciting things that are going to be the new forefront of what changes our world. And in the end, my favorite part of the story is at the grand opening, when the donor who gave us that challenge, we were standing here looking back at the building, he says, "You did it. That building defies gravity and it's reaching for the stars, and all of my stars are in the building delivering it." So thank you.
So I will say that in looking at that project, it looked like, as was mentioned, a challenge for defying gravity and innovation, and I think it's done in a very, very interesting, beautiful way. As a glass specialist myself, it's pleasing to see that sort of challenge and with design, and knowing that precast can absolutely look gorgeous. And I will also comment, was so glad to see your dual stage sealant joint on the precast. Just had to throw that out there really quick. Our next presenter, Samir Kumar, is a principal with TECHNE. Samir is a colleague of mine. We've worked on a project the last couple of years here in Washington, a project I think we're both very, very proud of. And Samir's talk is going to be on learning to unlearn, keeping up with the shifting paradigm in facade design. Really looking forward to this talk. So with that, Samir, you're up.
Thank you. Hello, everyone. It's such a pleasure to be here in DC, a city where I have worked for almost the entirety of my professional career on multiple projects, and I hold it very dearly to my heart. And thanks, John. It's a pleasure to be introduced by you. I am here really to share with you things that are sort of going on in my mind and in the world of facades, and I think that it's all super relevant. I think that with such an esteemed gathering, it needs to be sort of said out loud and discussed and all of that. So, but the nice thing was that I got here yesterday and I got a chance to visit the Wharf, where we touched a little bit on the project that I was actually extensively involved with when I was at Shop Architects as the director of facades. And it was a real pleasure working with Martina and the various teams that were involved with And what is unique about that project amongst the projects that we already looked at is that it was really the only core and shell commercial building, and therefore its form is relatively straightforward compared to the other projects. And therefore, we actually spent a lot of effort in finding meaning and finding visual interest through facade articulation. And there are a number of interesting moves that were made on the facades. We tilted the glass outwards and created a shingle effect. We arranged these bright anodized frames around the glass to create this sort of a ambiguity about whether the facade was vertical or not. We curved the corners to heighten the reading of the two facades as being part of one family, etc. And this is kind of in the nature of core and shell office buildings that the facade does end up carrying a lot of the burden of meaning and interest. We started this project right when we were finishing this project, which is when John and I worked together, which is also here in DC, and very similar program, very similar size of projects. And this also, being a core and shell office building, was very much about what the building presented itself through its facade. And here we were also interested in three-dimensionality of the surface. We were interested in an appearance that would change with time. It would change from the direction you looked at, etc. And here the material palette was slightly different. And the geometric strategy was slightly different, but very much to the same effect. In fact, when I look back on a large number of projects that I have been involved with over the past several years in my career, certain themes keep coming back, right? With facades, with the variety of materials we use, we're always talking about, these ideas of creating interplay of light and shadow. We are always interested in the role of changing time and changing appearance and changing direction of view and all of that. And we bring together a whole lot of aspiration through the variety of materials, through variety of techniques and craft and all of that to create uniqueness and recognizability in architecture through the facades. This is especially important and interesting because facades do not only belong to the building that they clad, they really belong to the city, because the building facade is what shapes the street level experience for the people. So even though a building may be occupied by, say, 500 or 2,000 people, but there would be millions more who would develop an emotional reaction based on the facade of the building, and who are your audience. And to some extent, facades, contribute to the overall image of the city. And so there is an inherently bigger agenda when we work with facades. And that is important to keep in mind as we talk about the other side of this coin, right? So, there is a social, emotional, political side to how we approach facades. But facades also are inherently a core component of the protective function of architecture, which is really the original reason why we built buildings, which was to shelter ourselves. And buildings end up performing that sheltering role primarily through the roof and the facade, the wall. And so the protective function requires that the facades also be performing, in addition to performing performing in response to a given set of expectations. And all of this sort of creates this duality that the facade must always deal with, right? The aspiration from the outside versus aspiration from the inside. The forces of the natural world versus the aspirations of the man-made world within. Anyway, just to continue my train of thought, facades become interesting because of this duality that they must always contend with. The competing aspirations, the competing needs of the the forces of nature versus the idea of comfort and the idea of human well-being and human experience. And as we go back to this, what I'm trying to get to is that we, just as we define parameters of what is desirable for facades in terms of its social, emotional, political performance, there are also well-established criteria for its technical performance that we are all familiar with, and a lot of us deal with on a day-to-day basis, which is constantly sort of playing a game of, it's like playing a game of back and forth, game of chess with the duality of facades. So amongst all the variety of technical challenges that the facades must meet, I am mostly interested to talk about the one that seems to be bearing heavily on us these days, and it is the one that seems to have the promise of appending everything that we thought we knew about how we build and what is the right thing to do and what will take us farther. And I'm specifically talking about the sort of this is not a new conversation. I mean, we all know that this has been spoken about. For a long time, we have been trying to frame the conversation about our responsibility towards the environment. And over the few decades that I have been a part of this profession, there have been different terminologies that have been used. There was ozone depletion at one point. There was biodegradability and recyclability at one point. So there have been different ways of trying to define what the problem might be. And it seems that we are all now ended up at this being the core, or the most urgent and the most pressing problem, which is that of climate change due to global warming. And I'm going to just quickly gloss over the fundamental facts about it, just so that we're on the same page, but I totally understand most of you already know this. We are specifically talking about the overheating of our planet due to excessive amounts of greenhouse gas emissions, especially carbon dioxide. And it really is said that it is believed, it has been established that post-industrialization, once we discovered hydrocarbon fuels, fossil fuels, and started burning it extensively and releasing all this carbon that had been sequestered in the fossilized underbelly of our Earth, we started releasing it into air, causing this rapid increase in the presence of these greenhouse gases in the atmosphere. So I think it is established without doubt, especially in the scientific fields, that this is that human activity and human choices especially around burning fossil fuels, is the reason why this is happening. The reason why it applies to us as people in the design and construction industry is because of all the various sources of carbon emissions. A large part of it applies directly or indirectly to the construction industry, right? So, building operations, of course, is by itself about 20% of the overall emissions, but a lot of the industrial production, what falls under the industry category, is also feeding the construction industry, and a lot of the transportation is also feeding the construction industry. So there is a large chunk of this that we have some sort of a purview over. We have, after a lot of back and forth, we have now, I think for the most part, for at least foreseeable future, come down to being able to describe the core problem in this very simplistic terms, that we're really talking about carbon as it is emitted into the atmosphere through the making of buildings and then running of buildings. And that basically has become or is emerging as the new metric for how good or bad a particular building or a particular material or any of that is. And usually this whole life carbon is spoken about in two parts, the embodied and operational. Operational carbon, of course, is the easy one because we all have been talking about it for a long time. We are all familiar with energy efficiency and as the primary goal for sustainable design for at least the last 25 years, right? And we have been focused on it. We have been focused on reducing the amount of energy our buildings use. Energy codes have been written about it. There are all these voluntary standards, the LEED and the BREEAM and the Passive House. Almost all of it is focused towards controlling the amount of energy the building uses, which in turn reduces the operational carbon emissions. So this is the easy one. The embodied carbon piece is the relatively unfamiliar, somewhat new piece, but one that is, there is beginning to be a little constituency of people who are actively talking and developing knowledge about it. Carbon Leadership Forum is the big one in this country. There's a whole bunch of conversation around the need for us to start counting carbon, accounting for carbon, and there's like all these various professionals coming up with ability to try and develop embodied carbon as a true metric of success of our work. But it, the part that is really important is that embodied carbon and operational carbon cannot be seen as two equally important areas of addressing at this time. And the reason for that is what is considered to be the time value of carbon. This particular graph shows this tall yellow bar, which suggests that for a building, the embodied carbon, which is basically embodied in the building upon construction, is already really high. And then whatever you do with the operational carbon afterwards over the several years of the building life is minuscule compared to how much carbon we put out in the atmosphere just to get the building built. And that is irreversible. We cannot take it back. And so the various agencies who are working and developing this knowledge are saying that we don't have time to keep building the way we built and keep putting all this carbon up. We must take embodied carbon really seriously right now, right? And that is because as time goes, this yellow bar will keep on hurting us much more than any care we put in controlling operational carbon. And of course, you can see the operational carbon bar keeps getting lower and lower because there is also efforts underway to decarbonize the grid, to go towards more renewable energy sources, etc. So operational carbon is really at this point what people in this circles, people believe that talking about operational carbon at this point is moot. So embodied carbon is really about how materials or how components of the buildings come to be, right? We know that materials follow a certain steps from their origin in nature or origin in a factory down to being installed on site. We all are familiar with this under other names like supply chain. This is basically supply chain. And we also know that at each of these steps, there is energy being spent in either running machines, combustion, or even running offices for people and people driving cars too. So at every stage of the supply chain, there is energy being expended, which is putting carbon emissions into the atmosphere. And in addition to what happens at each stage, we're also putting additional carbon transporting material from one to the other stage, because each one of these layers are entirely different industries that are located in different parts of the world. And today in this global environment, global supply chain, we are actually transporting materials across the world at the drop of a hat. And at every stage, we are therefore constantly adding to the overall count of embodied carbon. Basically, the carbon emissions from transportation, the carbon emissions through the manufacturing process put together loosely represents the embodied carbon of a material. So obviously, if, amongst the wide variety of materials, those materials that actually have to follow fewer steps to make it to site inherently end up being low embodied carbon, right? Because you've had less opportunity to emit carbon. And so inherently, one could, understand for the most part, with some exceptions, that such materials that, like dry stone masonry or rammed earth or log cabins, where you are taking material straight off the nature and employing it in a building, are the most desirable in terms of embodied carbon, desirable materials. But as you add more steps to bringing the material to site, you keep losing that benefit. For example, there are still materials like brick and mass timber or engineered timber or stone, dressed stone, which are still natural materials, and they are more or less in their natural stage with just one or two steps of industrialized production along the way. And they are still better. And then we have sort of the other extreme. I mean, it's a full spectrum, but the worst materials are the ones that go through a very complex, involved process of production, go through many, many steps, and you have to burn something, and then you have to pulverize it, and then you have to cook it here, and then you have to, melt it there, and then you have to do electrolysis, and, all sorts of things. And, cement, concrete is one of those, aluminum and steel, where you start with extracting the ore and then go through, cleaning up the ore and then smelting the ore and then electrolysis and then all of that. So those are the materials that we find to be the biggest culprits in terms of putting carbon emissions into the earth. So, if you were to take this into account and say, okay, what are the ways that I can, start to bring this into my thinking? the first one, the most obvious one, and the most meaningful one to some extent, is to start looking at what comparatively how the different materials that we might be looking at perform on a carbon scale. And a lot of this information is now starting to become available for free online. It does require that as architects or as designers or as contractors making choices about material selection, that we engage a little farther than we have done in inquiring and investigating what brings a material to a certain distance, which we never had to bother with earlier. For example, if you're looking at insulation, you can find information about all the different types of insulation, how they compare in terms of their industrial processing, and that'll start to give you some idea of how maybe you want to avoid XPS in favor of mineral wool. And you can take this further and you can look at comparative numbers across different material types to see how you could make a better choice. Of course, this in itself is also somewhat misleading, because what this graph shows is a comparison of every material for the same unit weight. So same 1 kg of aluminum versus 1 kg of stone. But of course, we know that the stronger materials, you use lesser of it, or lightweight materials, they end up being lighter. So eventually, if you had to build a mullion out of aluminum, it may only weigh 25 pounds, but if you had to build it out of stone, it may end up weighing 200 pounds, for example. And so this is not in itself the full picture, but it is a start. And then it becomes even more nuanced once we start going from base materials to assemblies. This is from Payette's wonderful software that they've made available called Kaleidoscope, where they have done an accounting of assemblies, wall assemblies, exterior wall assemblies, and at the very top you have masonry veneer, then you have other miscellaneous, then you have curtain walls, and then rain screen systems. Interestingly, something like limestone, for example, appears twice. One where it is used as a 4-inch thick masonry veneer, applied with cement mortar, most likely, which is why it has a much bigger carbon footprint, compared to the rain screen at the base, where limestone is probably 1¼ inch thick or 2 inches thick and applied with small stainless steel clips. And you can see how the same material, depending on how you employ it and what you do with it, you could significantly change its carbon outlook. And, curtain walls, glazed assemblies is a great one to look at, because, we're talking about it a lot here. But as you can imagine, the same process that we've been talking about, if you just looked at glass, you can imagine that at every step of processing glass, you're going to keep adding a little bit of carbon emissions to it. So, maybe it starts telling you a little bit about how to go, what are your high range carbon options versus low range carbon options if you're trying to determine what you should do with the glass. But then you look at it as an overall curtain wall, unitized curtain wall carbon footprint, and you realize that glass actually represents the small 10 to 20% portion of it, because aluminum takes the cake when it comes to embodied carbon in curtain walls. And these 3 bars already show how you can further improve that, how you can make aluminum hurt less just by adding more recycled content. But you still cannot, it still is a big number. But that is not all that we can do if we had to start addressing aluminum. Of course, keep in mind that what we are talking about here is simply what is within the purview of us as designers or as building industry professionals. There are other major efforts underway to try and electrify aluminum production, and then try and decarbonize the electrical grid so that the electricity consumed for the electrified production of aluminum, all in all, will keep shrinking this red bar favorably. So, everything that we're seeing here is already in transition and is being improved slowly across the board. But that still leaves a lot on our plate that we could do. For example, this wall, beautiful wall. The three-dimensionality of this wall we achieved was primarily through aluminum extrusions, right? Deep aluminum extrusions that enabled the glass to rotate out of plane and break the flat facade of a building into this articulation. And, today, would I do this knowing what I know about carbon and aluminum? Not sure. I find this building more interesting, which also breaks the plane, but it bends the glass, gives it inherent stiffness to an extent that it eliminates the mullion altogether, right? It is one could argue that it is a smarter way of utilizing what you have on hand. And you can still, get a lot of mileage, in terms of architectural expression. And I was not involved with this project, but it is a beautiful project nonetheless. These are projects that I was involved with, where we were looking at these fluted expressions. On one hand, you have a fluted expression made out of extruded aluminum. On the other hand, you have a fluted expression made out of milled marble. Okay, so there are inherent benefits here. So all of this is, we're still talking about the same goals, overall goals for what facades need to do and how we continue to meet them. I'm going to rush through this. All of this is summarized by saying that it is not simply about the choice of material, it is also about how we apply it and how we assemble it. And we can continue to address embodied carbon. The next step is how we think about overall facade systems, where we have been thinking about energy efficient facade systems for a while, where highly insulating and highly airtight systems were a slam dunk all this time, but they were all actually only focused towards operational carbon, especially all of our energy codes and things like passive house that force us towards thicker and thicker facades, more and more insulation, more and more triple glazed units. If you put it in the context of embodied carbon, you find that none of this will make sense anymore. Why would you employ triple glazing if for 60 years you will not see the benefit in terms of embodied carbon compared to double glazing, even counting the energy savings that comes from it? And how, on the other hand, we are also now discovering new paradigms in design of facades and design of buildings, workspaces, where we're talking about perforated facades, letting air flow freely through our facades. This is a project that we worked on for the Uber headquarters. This is a project that I'm currently working on in Santiago, Chile, where we're doing a very perforated facade with solar chimneys in the back, where we are going to employ natural air, which will develop a current using solar heat to passively expel air through the building. So one could argue that maybe a future facade which is lightweight and airy and not super insulative and not super heavy and airtight may actually be better, not only for human health and well-being, but also for the idea of embodied carbon. So there is a whole conversation that can be had about overall facade system design in light of embodied carbon. And then the last part of it is how we buy these facades and how we procure them and how we are all used to performance-based specifications and how we are all, performance-based specifications gives a clean break between architectural intent and the autonomy the contractor has to buy materials. Will that stay the same? Because we cannot talk about embodied carbon without talking about supply chains, no matter whether we are a contractor or whether we are an architect. Does Does this start to blur the boundary? Does it start putting additional risk, additional burden on the contracting side as you go through this? So just to round it off, there is the fourth way, which is the procurement of these facade types that will draw from us the best of our abilities to innovate and try to set a path forward. So this is what I really meant by learning to unlearn, because I feel like everything I know about facades needs to be upended very quickly, very soon. Thank you.
Thank you, Samir. That was excellent. A very, very important topic that I know will be and is continuing in our dialogue, and hopefully will be something that our second panel will be touching on this afternoon. So without that and any further ado, I'll introduce our next speaker, Laryssa Dilozir. Not too bad, who's a professional engineer consultant with CDC, and Laryssa's presentation will be on failing metal panel systems and remediation of an occupied building. So with that, Laryssa, take it away.
Hi everyone, my name is Laryssa Dilozir. I'm a PE and I've been with CDC for over 10 years at this point. I'm here to tell you about a very interesting project that I worked on, ironically through COVID. It is definitely different than things you've seen today. It's basically every architect, owner, and general contractor's worst nightmare. So it'll be about a building that I cannot particularly disclose its location. So the summary of this project, it is located somewhere on the East Coast. That gives you enough states to consider where it could be. It's 15 stories, and closeout of the inspection of the building was in 2014. It's overall a unitized glaze system. It's comprised of captured glazing units as well as metal panels. The metal panels are located on every odd floor and at all of the column locations. Our company was contacted in January of 2020 to review conditions on site. Why, you may ask? If you look over here, it looks like everything is fine. But as you continue in, you start to notice something is amiss. An entire metal panel had blown off of the building, right here. So on January 16th, 2020, there was a wind event that was approximately 32 miles per hour wind speeds. On the west elevation, there was a panel that had detached along the column line. It thankfully did not hit anyone. It landed in the alleyway, but again, this is something that is never supposed to happen, where the facade comes off of the building. And as you saw, it's all the way up on level 13. So thankfully, there was no damage to anywhere else as well, but it was a very serious issue that we had to figure out what happened and why. First, we took a look at the recovered panel. So on the mezzanine, we went and saw what had come off of the building. It was an 8-foot, 4-inch tall panel that was 2 feet wide. It was a 4-millimeter thick ACM panel, so aluminum composite metal panel. Stiffener spacings were varied from 7 5/16 of an inch all the way to 21.5 inches. They used VHB tape as a method of connection at the stiffener locations to the back of the panel. As you can see from a closer look of this edge over here, you can see that the panel had sheared through those corner connections. On the sides of the return, the whole edge was buckled. Right here is along right here. After that, I went and took a look at the actual building. We went up on a swing stage. Thankfully, winds were just under 18 miles per hour, so it was a little chaotic, but it was okay for us to be up there. And as you'll notice, these joint sizes were not consistent across. And even more concerning, at the corner returns, there were a bunch of fasteners and abandoned holes that were not entirely sealed in that joint. Going further up, at the level 13 location, this is what we saw. This is every person's worst nightmare. You would think that a metal panel that had been fabricated in the shop in a controlled environment wouldn't have these sorts of issues. But looking down, you can see that there was issues all the way across. All of these films that are blue here were the brake metal protective films that remained in place, which you could see on the edge and on the top. And here's where the VHB tape was located. This is the backing of the tape, which means that they did not remove it, and so it was not even connected to the panel. So when we look at the alignment of the stiffeners, each stiffener sort of had its own issue. We had the blue film on the back here, so there was no VHB tape here, but it was still on the panel. This panel was sort of a twofer. It half remained on the panel, but stayed as well on here. Partially, it was adhered at this location, and then at the bottom, you can see that there was no VHB remaining on this panel because it was still in the stiffener. So after that initial visit, we found that there were 7 points of connection originally. Only five of them were improperly connected. And so that led to failures with shearing through the top and bottom return edges of that ACM skin, as well as adhesion failures at 3 different locations. So instead of transferring load at 7 points, we had 3. From that point, we started discussing a test protocol to see exactly how widespread this issue was. At that time, COVID hit, so everything came to an abrupt halt. There was no movement for a while, and everyone sort of had to hope for the best that there wouldn't be any other incidences in the meantime. But during that period, we were able to come up with a way to figure out how many panels were impacted and where. So the test protocol was developed where we made sure to test the vertical panels and the horizontal panels. They each had their own markers so we can designate where we were looking and at what location. We made sure that the loads on the panels were consistent with what was expected to be loaded in those areas. So we looked at original calculations, the original shop drawings, cross-referenced what the loading anticipated was on that building, cross-referenced what we could do to test it, and how we were gonna move about it methodically. So this was the testing apparatus that we used. There was a third-party testing company that was brought online, and they put this together with some help from me and the design team. So they used this really innovative I-shape beam here that they were able to take these 2 horizontal legs on and off as they needed to test the horizontal areas and then would remove them to test the verticals. They had a load cell that would be applied with a suction cup to the face of the panel to that load that was specified. I believe it was about 130 pounds for typical areas and then 180 at the corner zones. As we were going about the testing, we also did some bore scoping. So we would drill a tiny hole at the bottom of the panel so that we didn't have to necessarily destructively remove all of the ones that were installed. And it gave us a better look at the behind the scenes of what was going on. So we didn't have to go and test every single location, but the ones that we were testing, we could see what the connection parameters were. So this is some of the results from the bore scope testing. Each one, you can see that the stiffener is a full sort of panel condition. This was a vertical joint where you could see daylight coming through. Here was a condition where there did not appear to be any connection between the stiffener and the panel. Here you saw all of these different stiffener brake metal pieces, and this was the back pan to the interior. And at this condition, there was definitely no connection between the stiffener and the panel. So some of the other conditions we saw was more of that blue film that we saw in the initial review of the site, and then also that there was not necessarily backings that were peeled off of that VHB tape. Here's what some of the for-record shop drawings look like. This is a plan view, and as you can see right away, that stiffener layout does not match what we saw in the field. This was made of 3 different angles where this entire cavity should have been open. If we get a closer look, they were supposed to be 1 inch by 1 inch aluminum stiffeners. That is not what we saw. Going back to what we saw in the borescope, We had these brake metal panels here, which again, perhaps structurally not such an issue, but it still didn't match what was approved. So here we have a typical horizontal panel test. Just to give you an idea of what we saw when we got out there, we had a little dial gauge that was able to measure the deflection, and then we had our load cell placed right in the middle. Could you press play for me? It's in the bottom one, yeah. Yeah, so as you can see, they start applying the load. The little dial gauge starts to compress, and then they take measurements of where that was. They ran these cycles at, I believe it was every 30 seconds. They would apply the load, hold it for 30 seconds, and then release it for a minute, and then they would do that for 3 times. If the average of those deflections were greater than what the allowable was, then it was considered a fail. In conditions where we could tell that it didn't appear that the connections were matching what was in the shop drawings, we would do a pull test to visually see the bowing and not have to go through the process of setting everything up. There were some conditions that we saw that were very clearly not acceptable. This mitered edge was entirely cut through. Someone was able to put their tooling knife through it, and that's not supposed to happen. So for the vertical panels, they used that same structure of the eye versus the same structure as the horizontal, but they would remove those legs, and then they had the 2 different orientations. The H at the top of the fins, and then an I lower down for the middle of the panels. They had the dial gauge set right near the load cell, and then they had the output just on the swing stage. Could you play this, please? So here's a video of a really bad vertical panel that we tested. As you'll notice, the apparatus was not set up, and someone was able to just put a suction cup on the face of it and give it a pull. It was very bad. Panels are not supposed to do that. Deflection should have been maybe 3/8 of an inch, which is not very clearly visible. So there were times where we didn't even have to use the apparatus we had created. We could just pull on it and know that it was a failure. Here's another one where it was again very clear that the panel was not properly attached. It deflected over 3 inches, and for effect again, you can see that differential. There were some other conditions where the 2 panels were bowing twice, were not connected at the joint, and so it was a double bowing effect, so they were not properly secured either. We had VHB backing tape, again, not supposed to be there, so that stiffener was not even connected to the panel, did nothing under suction, and in other cases, they didn't even have the VHB tape on there. Alignment was also an issue, but at this point, it was so far down the road of a consideration that we just acknowledged it and moved on. We had in and out misalignments, and again, tolerances are typically within 1/8 of or 1/4 of an inch. We were well beyond that. Our conclusions, you can see from all of the red, most of the panels we tested failed. We tested 110 vertical panels, which was 23% of the total vertical panels on the building. And then we tested 69 horizontal panels, which is approximately 8%. 85% of the vertical panels that we chose at random failed. The horizontal panels were almost not under consideration, but the owner wanted to make sure that those were acceptable. Good thing we did, because 41% of the ones we tested also failed. So the next step of the process, which took approximately another 6 months, was a second consulting team was brought out to review the facade, try and gauge exactly what conditions were installed to try and work with that for replacing the facade and to figure out the best way forward. They used varying methods from a borescope to a stud finder, which, just for everyone's general knowledge, does not work because stud finders do not work through metal, which is why the borescope was necessary. They also used a rubber mallet to hear by sound when it was a cavity versus a stiffener, and then in other times they just straight cut through the panel, removed it, and took a look inside themselves. So once they got that information and we worked through all of the different conditions and situations, they found that they were going to replace the entire exterior metal panels of the system. That included copings, floor slab levels, vertical column panels, and the level 3 panels, which were taller than our typical horizontal slab covers. The shop drawing and calculation process took over 8 months with a large team going back and forth and seeing what would work best for what was still installed, while also making sure everything was now structurally sound and properly connected. When they actually began the installation of the whole system, it took about 4 months, which included everything from the temporary scaffolding, the shop drawing, finalization, to fabricating the new panels. They were able to remove the existing panels, install the new supports, install the new panels, and everything was completed by the end of 2022. So as you can see, the verticals were all removed, and so were the horizontals. The good thing about this project is that there was a back pan that acted as the barrier between the interior and exterior face of the building. So lucky for us, there was no disturbance to anyone or any of the occupants within this building. We were able to do all the work from the exterior, and surprisingly, there weren't leaks as we would have anticipated. But again, it worked for everyone on the design side because they were able to drop the building, remove the panels without any excess weight or excess issues, and then once they got enough panels removed, they would go ahead and see what the conditions were and then make remediations to that structure as needed. So over here, we have that typical horizontal. Not exactly sure what these extra pieces are, but they were in there. And here was a section cut of that large level 3 panel, which again, not very much extra structure for being a taller panel. So when needed, they installed the substructure to make sure that all of the horizontals were properly supported. At the level 3 panels, you can already see that they had additional substructure in here, which are these little verticals, and that they were able to cut it out the existing panels without an issue. At the corners, they had to get a little bit more creative to make sure that they jointed and were held on correctly. So it was engineered and designed to have angles that basically came off of the substructure, went through the existing mullion, and didn't impact the water line at all. At the horizontals, they were able to remove all of the existing panels, install any of the substructure that they needed, and make everything look new and clean while matching the existing structure of the building. This was a unique case. It was up at the roof level and they had a scupper. So they were going to just cut a hole and install it, to which we said, please do not do that. And so they made sure to brace the opening and have the additional framing, which was significantly more supported than those panels had been originally. And here's what that looked like when it was installed. Very nice if you ask me. The vertical panels, you can see here that they had started installing the new verticals, and here is where they had done some of that destructive testing, which you'll notice looks pretty bad. But the good thing is they were able to come in, install that substructure, and get everything where it needed to be. And this was that cross section where they were able to use the existing structure and then just connect in the new panels that had an extrusion around the exterior and were much stiffer and were much more well connected than they had been previously. Here's some of those photos after the verticals were installed. This was a unique condition since it was adjacent to the curtain wall here. And this was what we found when they removed those panels. It was open to the building, if you're wondering, but they were able to access that location, install a ceiling joint, and then continue with the installation of those vertical panels. Here's what it looked like when they were on their way, and you can see that there's no longer a hole into the building. They were able to put their joint at the exterior, and they had a much better performing building moving forward. At all of the horizontal joints, they made sure to install the sealant more for visual than for performance. But again, everything looked very clean. Everything was properly installed. Here's a view of that scupper zoomed in. They sealed around that opening so that everything looked consistent. Here's a vertical joint, which visually was not my favorite, but it was installed correctly and tooled cleanly. And at the end, we had a fully completed building where all of the metal panels were replaced. Overall, the look of the building did not change. It stuck with the original design intent, but everything looked significantly better because it was actually aligned as it hadn't been previously. Everything was structurally installed. There were no concerns of anything falling off the building. So again, if you ever recognize this building and you walk past it, you wouldn't have to worry about it now. So the lessons learned, shop visits are very important. You need to see what's going on in the field. Testing in the field is very important, especially during installation, to make sure that they're keeping up with their QA/QC. Selecting the lowest bidders is rarely the best option. That was a previous situation that happened here. Bonds and insurance are also very important aspects of the construction industry. They were utilized in this situation. And if you ever have a shop that's not allowing site visit or shop visits, or if they seem like they're hiding things, it's going to come to light eventually, hopefully not in this manner. But if something is being hidden, it's going to come out. I learned a lot about the remediation with the testing protocol, the apparatus, and in-field structural testing, which I hope no one ever has to do. It is very stressful. And the new installation without being disruptive to any of the occupants. Thank you, everyone, and please contact me if you have questions.
Thank you, Laryssa. That was great. It's certainly a challenge when you end up with projects that you need to sort of have to work with in the field and remediation. And so yeah, very, very important lessons to be learned for projects like that. Just a quick announcement. There is AIA signups right out at the registration desk. So please be sure to sign up for 6 credits for participation in the event today. And our last panel of the day is titled Climate Action in the Capital, Sustainability Through Facades. Certainly a really important and exciting discussion. Really, I think, talking from Samir's presentation, who I think gave us a great introduction to the topic. And, an important reckoning, I think we all as designers and folks who help enforce the building code and give recommendations to clients for, really being able to be aware of the energy that actually takes to get facades on the buildings, take them off the buildings, and how they perform in service. So with that, I will introduce, I think we're all set up here, our moderator for the panel, Heather Haregi. Did I pronounce that correct? Look at that, not too bad. Who's the Director of Sustainability and an Associate Principal with Perkins Eastman. And with that, I'll pass it over to Heather.
Well, thank you everyone for sticking until the end. We're excited for this last discussion, and hopefully we'll make it fun, a little bit fun for you, and then we'll get you kind of on your way. But just to kick it off, I think let's go and do a quick round of introductions. I think we brought together a very diverse panel for this last session to talk about sustainability from a lot of different perspectives. So I want everyone to kind of give a round of introductions, and then we'll all be kind of chiming in throughout the conversation. So I'll start with Andy.
Hi, good afternoon, everyone. I'm Andy Doyle, Project Manager with MCN Build. We are a local design build general contractor. Offices in DC, Baltimore, Prince George's County, and in U.S. Virgin Islands. And we are approaching $1 billion in backlog. So we're quite happy to be growing along with everyone else in the industry.
My name is Brad Carpenter. I'm a senior principal with Simpson, Gumpertz, and Hager here in our Washington, D.C. office. Building enclosure division of the company that we do building enclosure structures, materials, and specialty structures.
Hi everyone, I'm Ruth Hong. I'm the SVP of Development for Gyre Lynch Real Estate Partners. We're a DC-based real estate development company. We've been in business for about 25 years, and we do all sorts of different types of development, new construction, renovation of attainable housing products, market rate development, office, retail, multifamily.
Hi, and good afternoon. I'm Roger Chang, a principal and DC office leader for Burrow Happold. We're a multidisciplinary international firm with about 400 team members in the DC and US area. We're currently helping DC develop its next clean energy DC version, and it's something we'll talk about in our panel discussion today.
Okay, so sustainability, let's define what that is. I think a lot of times when people hear the term sustainability, all of you are gonna have a different interpretation of that in your own head. A lot of times it's based on energy. Sometimes there's the little like lead person that's telling you that it's just lead. But for us, and for this panel in particular, it's more than environmental value, right? So it's also the intersection of social value and economic value. When you look at that way, it's, you know, when we talk about social value, it's bringing in health and well-being of the occupants, it's thinking about community and equity and making sure that we're looking at sustainability through that lens. From an economics perspective, it's making sure that we're thinking about holistic cost of the building. So how can we deliver reduced first costs, reduced operating costs, and look at potentially HR costs and marketing value, layer that in to get a holistic assessment of what is economic value. And it is, of course, also environmental value. So looking at reducing our resources, reducing our impact on the climate, and improving habitat where possible. So really, when you look at sustainability this way, it is everything. And it's really a lens with which we can approach design and with which we can approach our conversations from here on out. So that's how we're going to talk about sustainability. And when we talk about sustainability through facades, I want to just kind of set the stage for our conversation today by talking a little bit about this point of what is the role of facades in sustainability. We're going to come back to this a little bit later on in our discussion, and we'll have a little bit of a round robin to talk about the many roles that facades have to play and how we want to think about them more broadly. But for now, I just want to introduce this idea of kind of two different perspectives of how to look at facade design. On the left-hand side here, you see more of like a passive design purity, right? It's using its context and nature to design a facade that is responsive, but that can deliver on energy goals, comfort goals, etc. Another solution to that, that's using design and using, how we design to make sure that we're able to deliver on sustainability. On the far right, this is, taking a different approach. It's using new technology to be able to deliver on comfort indoors. So it's sort of like a contrast here in terms of passive design purity or innovation, and when we consider sustainability through facades, what is the right pathway forward? So this is just, with this in mind, I think we'll go through our panel discussion and see what conclusions we come to on that front. So we've gathered a panel of experts today that range from contractors to engineers to developers with one main thing in common, a commitment to sustainability, and with experience implementing that in Washington, DC. So I want to pass it over to Roger to give us a little bit of an introduction into the aggressive climate goals that DC has put into place here and what we see coming down the pipeline and how we're preparing for it.
Thanks, Heather. As you can see here, it's an exciting time. It's been a decade since the first version of Sustainable DC was released. This further was evolved in 2019. And in that interim period, there's something known as Clean Energy DC, which was released in August of 2018. It outlined a series of policy drivers and measures to focus on three different parts of our energy sector: transportation, renewable energy, and buildings. And buildings use about a significant amount of greenhouse gas emission potential within Washington, D.C. And you can see that the policy drivers that were indicated address both new construction as well as existing buildings. And so we have a very aggressive energy code, as many of you have probably experienced in the DC market, as well as a new building energy performance standard that's within its first cycle that addresses existing and historic buildings. This is a snapshot of emissions in 2019. So like many urban cities, we have a much higher contribution from buildings to greenhouse gas emissions than in other parts of the country. About 70%, about 2/3 to commercial buildings, and 1/3 to residential buildings. This shows how emissions have tracked since 2006. So we see we're on a pretty good trajectory. There are very aggressive goals. Originally, a goal in Clean Energy DC was getting to zero emissions by 2050. The mayor pushed this forward by 5 years to 2045. So there's a lot collectively for all of us as a design, construction, and owner community to continue to align with this glide path. This is the first in Washington in the country to be announced. Boston, New York City, several other cities around the country also now have existing building performance standards. For Washington, D.C., this starts out with buildings over 50,000 square feet. For the public sector, buildings over 10,000 square feet. And then every 6 years, a new set of standards is released, and a wider subset of the building stock has applicability to this standard. So in this next slide, we can see how our building stock is performing in Washington, D.C. right now, just a range of different building types. For multifamily housing and for offices, we see pretty high performance, higher than the national average or median at an Energy Star score of 50, but there are also other building types that don't perform as well, and there's a lot of opportunity there, especially with the role of integrated design and the contribution of facades to that. We do have the benefit of a lot of great data to work with. It's an initiative known as Open Data DC. You can look at different dashboards like this and really filter performance of buildings by building type, look at energy and water use. Very powerful because you really can't manage what we don't measure starting now. This really shows that there are a range of sustainability frameworks that we can use within the industry. The LEED rating system is very well used within the DC market, but now we're seeing a lot of interest in other systems that may fill gaps that the LEED rating system doesn't completely fill. So you see across the top 7 different topical categories, and the bubbles show the relative intensity of focus within each of these rating systems that you see on the screen. Living Building Challenge, ILFI, Zero Carbon, Passive House, all have a very strong push on reducing operational carbon. And as we heard earlier today, embodied carbon is now entering into the mix of focus. And so we see there are some frameworks that address that much more strongly. Now, we all experienced this incredible pandemic the last couple of years. So health and well-being are items that systems like WELL, Living Building Challenge have a stronger focus and interface with. And then lastly, building electrification, I think, is also on all of our minds. And the way to focus on this is understanding the local grid emissions, figure out the impact of buildings and its energy use on electric demand, applying technology, whether it's with a facade system or HVAC systems, or even how we just collaborate with each other, all come into play. And of course, cost, not only first cost, but life cycle costs are tremendously important. On the next slide, we see the range of emissions factors across the United States. So whether we're in Wyoming versus in Vermont, all the way on the right, will impact how we may think about electrification and the timeline to electrify. Washington, DC, we fall in the middle. All the green dots show a location that has a renewable portfolio standard or a climate action plan. So Washington, DC, as the grid gets cleaner, it's even more benefit that we'll see with electrification. But we can't electrify just by applying space heaters or electric resistance heating. We have to do this in a really smart way, and that really starts with demand reduction. Huge contribution from facade systems to that.
Great. Great. Thank you so much for that overview. I think this has been changing a lot of the conversations that I've been having as a sustainability specialist in DC. And I think for the better. It's exciting now that this legislation is coming through and we're starting to see changes, both in terms of how our clients are thinking about talking about sustainability and how we're interacting with them from that perspective. So on that note, I think, Ruth, I'd like to turn to you as a developer and talk about how these changes have been changing your thinking around sustainability or changing your business as usual.
as a developer, we're obviously concerned about upfront costs, but we also need to look at the long-term viability of the project. So we're looking at operating expenses and utility usage is obviously a big factor, and how it also trickles down to our residents. Right? So most of the development we do is multi-family, so we're kind of thinking about like the whole package. Now with all this new work in VEPs, we've done a lot of brain damage thinking about the prescriptive path or the performance path, and my conclusion is that it's absolutely clear as mud. And so, and it almost varies depending on the project too, which pathway is the best way to go forward with. One project that we have in DC, it's at the Reservoir District, PK Mellon. You guys are from the area, know that one. We have one building there. It's a multi-family building. It's wood frame, 5 stories over a 1-story concrete podium. But it's like a E-shaped building. So imagine that 2 of the legs of the E are Mercury, and the bottom leg, or maybe negotiation right now, is an affordable housing component. So that comes with district subsidy and financing. So that the affordable senior project actually has some additional sustainability requirements. EGC plus, passive house type thing. We ended up kind of negotiating and getting to like a gold standard plus it's called the zero energy free home. And so on this project, because it still looks like one building from the outside, right? It has 2 lobbies, it's still one building and part of the podium. We had to really wrangle and figure out how do we make this work for both the market rate component and the affordable component. So the market rate component is performance-based, the affordable component is prescriptive. And so there's a lot of baseline things that they do, but on the affordable piece, we actually had to go to a central hot water heating system. We have Energy Star air sealing requirements that you don't have on the market rate component. We have solar panels. Insulation is kind of the same all the way around it. There's definitely some differences and some cost factors that we have to look at that, depending on the type of project we have, it tends to vary. So it's not a straight answer, but we have to look at kind of the whole spectrum and see what the requirements are, and then later on how it impacts upfront costs and long-term operating expenses.
Yeah, definitely. And I think, so Roger was mentioning there's kind of multiple streams to this new legislation. One is certainly new construction and new code requirements, and then one is existing buildings. So we're talk about the existing buildings a little later, but as Ruth was talking about, let's go down this pathway of new construction and how we're seeing changes as a result of that in DC. So you mentioned Passive House briefly. Brad has actually done a lot of work in Passive House in the DC area. So would you mind telling us a little bit about your experience around that?
Sure, and hopefully everybody can hear me. The interesting thing, I think I'd like to first take a step back when we look at building enclosures. We think about energy consumption, and now, of course, that's being translated to embodied carbon. But if we think about energy use in the building facades as a major load, right, a major load that needs to be resolved with the mechanical system, but it's also very much an outward-facing embodiment of the design intent for a building. So it's very important. But when we think, well, how did we get here? How did we get to today's practice and how we do work today? Well, we think about it from energy modeling and maybe performance-based design. There are prescriptive paths for the enclosure, but they tend to be relatively limiting to the design professionals. And so performance-based design arose out of that and thinking about different energy modeling techniques in order to evaluate the relative impact of the enclosure on the overall energy consumption for a building. But that was really driven by the code. It was driven by the building code saying, can you meet the equivalency to a baseline building? And energy modeling from a standpoint of looking at equivalency is fundamentally different. In fact, if you read ASHRAE Standard 90.1, it'll tell you so. It's fundamentally different than energy modeling as it relates to determining in-process use, right? How much energy is the building actually going to use in process, comparing it to a baseline versus how do we anticipate? And so understanding that and thinking about how we evaluate designs and how we evaluate the contribution of the facade, we actually need to do better. We need to do more than just meeting sort of a prescriptive requirement against a baseline. We have to employ tools that are far more sophisticated, have a better understanding of the technologies that are involved in order to get a more accurate result of what might happen in service. And a little example of that is, I do see from time to time in some of our investigative work, a building that is code compliant. It's a beautiful building, high-end building, lots of wonderful, talented individuals involved in the design and construction of the building. But when the building is built, maybe a glass facade, there are other systems as well, but once you get the building operating, if it's uncomfortable to the occupant, if we think about it from sort of these three various perspectives of comfort and sort of our social side and our environmental sustainability side, as well as from our performance standpoint, you'll realize that if it's a poor performing building, if people are uncomfortable in it, it's never going to be operated the way that it was intended. People are going to be fussing with the mechanical system set points. People are going to be bringing in space heaters, and it's really going to be a mess. So it's never going to actually arrive at what was intended from a performance standpoint. So we have to fundamentally think differently about how we model, how we develop expectations for performance, and really sharpen the pencil on how we do that in order to be successful. Because really, if we're going to improve performance, and if we're municipalities like Boston tying Passive House into the code compliance pathway as a means to make sure that we're using the enclosure in a way that is really optimizing its performance relative to the overall project, as opposed to using a trade-off to sacrifice in one area in order to offset it somewhere else. Really pushing the whole thing. And so Passive House has in it, and there are other similar standards that have in it, not only a modeling and performance and really focus on the air barrier, really focus on a good thermal envelope, but they also look at how do you implement it in construction? What are the quality control procedures in order to make sure that that actually gets initiated in construction and then in the operational side? And so focusing on that changes not only the relationship in the design of how we analyze it, but also in how we construct it and how we operate it down the road. And that, I think Andy can touch on this a little bit about how a construction team approaches a project that has really high expectations for the enclosure system performance and really, fine-tuned performance expectations. So I'll turn it over to you, Andy.
Am I on? Yeah. Thanks. It's interesting to us when we go after design build projects, and we have a number with our partners here. It's interesting that after the client presents the project through rose-colored glasses, everything's perfect. You have to meet all these goals and requirements. If you have a large site and you have lots of flexibility, everything's fine. Everything works together, like the Banneker High School job in the Shaw neighborhood. If you have a restricted site, all of the objectives, all of the client's objectives become pressured from various points. So that at the end of the conversation with the client initially, the compromises have to be made. It's interesting to us how far down the road we get sometimes when key members of the team are unsure of what our goals actually are. So it's really important to us that we get those clear. We really can't. The train can't leave the station until that's taken care of. And from there we can assemble the team. It's the owner's rep. It's the owner's rep commissioning. The owner's rep's commissioning agent. It's our team. It's the architect's team. It's the sustainability team. It's our commissioning agent, our supervisors, our subcontractors, and really most importantly, it's our QC program, which really is integrated with our commissioning team. So once everybody's in place, we can go through a final design review, working closely with the client so the client understands what we're doing and where we're going. I mean, that's really at the point where we can really start building the system. Scheduling the project, we have many schedules for our project, especially the major projects and $100 million projects. We have dozens of different types of schedules all tied into our master schedule, but we break out a commissioning schedule. It's a separate commissioning schedule for MEP and a separate commissioning schedule for building envelope. we break the building into quadrants, sections, that sort of thing. And in that vein, we also look at with the design team areas that we've identified where we could have potential problems. That's material intersections, it's components, it's assemblies, curtain walls, doors, louvers, all of those things. Those get special attention when we're planning our work. And then, of course, the final commissioning schedule and the testing matrix is interlaced with our schedule, so that everyone on the team knows what's going on. In the application phase, that's really where everything happens. We have a thing that we do called process training. And process training is where we determine in what order everything goes in. And it's interesting to think of. A tradesman will look at a plan and say, I've got to do this bit of work. And he'll put his own spin on it and do something on his own unless we stop him. We don't let people do that when we have these really high goals of performance. We talk about things like, for this, they were talking rain screen wall above grade. So is the drywall hung horizontally or vertically? Are the joints taped with a drywall product, or are they taped with an air barrier product? At what point do we do pull testing on the air barrier? That sort of stuff. We get through that in great detail, so everyone understands what we're going. We also work on the workflow for how the work is done. We enlist the tradesmen and mostly the trades foremans to work with us on this workflow confirmation, which pull planning is what it's actually really called, and the final schedule by quadrant or sections develop from that. What we do a little bit differently is that we really create sort of a chain of responsibility for the work that occurs. The framer who's doing the light gauge framing and the sheathing, he finishes section 1A, and he goes into our project management system and says, I'm ready for inspection for this first section of work. So our QC team goes in, creates the inspection, and we create either non-compliance or we approve it to proceed. Next step would be the first layer of air barrier. How does that go in? At what thickness? And then that work is done and signed off. The air barrier itself, how much area can the workers do in one day? At what point do we test the air barrier? Do a pull-off test for the air barrier? It's a system that has worked really, really well for us. What we have found is that one of the keys is the process training, because the tradesmen really need to follow sort of rules of engagement for how the work has to go together. Otherwise, there'll be too much diversity in the way the work is put together, and it will cause us just problems down the road. So that's the kind of order that we introduce into the process. And really, at the end of the day, I mean, we're tracking non-compliances, of which there are not often many, but we're tracking those throughout the whole project and quickly remediating those. At the end of the job, everyone feels good. There's nothing to go back on, and we've met our goals. Then, of course, the final testing occurs, and we see where we are. But typically, we're pretty successful.
I want to brag a little bit on MCN and on Andy, because the project that you mentioned, Benjamin Banneker High School, is slated to be the first net zero energy school in DC. The PV panels are currently being installed, otherwise it would already be net zero. But through this project, I think it was really interesting. We were in a design build partnership together from early stages. We were talking about what are the goals we're trying to meet here from a facade perspective. And I think we kind of scared you a little bit around the metrics that we were going to put into the specifications that we had to deliver from an air infiltration standpoint. So we put a 0.15 CFM per square foot requirement into our specifications. We, detailed it and worked with them early on to talk about how do you want to build this project. Let's talk about constructability and everything like that. And then the rigor with which they followed through with that on the construction site was impressive. And at the end of the day, project at the final blower door test came in at a 0.0875 CFM per square foot, so about half of what we had specified, which was incredibly impressive, and it's due to the rigor of the process that Andy just described there. So I think what I will say on that front is it can be scary at first, it can be daunting at first, but it just takes good partnership and kind of working together and good oversight to make sure that it can be delivered. So this is achievable, and now we move forward on many other projects and are also successful at hitting the goal. So I just want to note that there. So before we move on to talk about existing buildings, I think we've been referencing many other roles that the envelope plays in regards to meeting our goals and targets, more than just energy. So I'm wondering if we could go around briefly and hit on a different role that we see the envelope playing that we consider heavily in our work. And Brad, I'll start with you.
I talked a little bit about occupant comfort, and I think, there's a lot of benefits to glazing and facades, right? A connectivity to the exterior. We're talking about a positive work environment in office spaces. Daylighting, obviously reducing the demand on artificial lighting, improves that environment. But the careful balance of, the daylighting process, the solar heat gain during heating months where we need and can use that added information versus not. So I think, from a standpoint of balancing it dynamically throughout the whole year and not looking at it at one point in time is I think an important consideration.
Looking at new construction, building systems can represent 30 to 40% of the cost of the project. And so be able to right-size systems becomes so important, especially with the experience we've had with just low floor-to-floor height in Washington, D.C., whether it's new or existing buildings. Be able to start very early at managing that load demand helps everything to fit better. But then I think that helps the interior design team and architectural team be more successful in creating a wonderful environment. There's always that pressure of what's your final finished ceiling height, but I think by having a good envelope well considered, it allows the building system to actually step back and allow other magic to happen in a building.
Great.
I'll give one example too, and this is important as well when we think about building systems, right? Our energy code is pushing us to be more efficient with our mechanical systems, with our building systems, and there's no longer really an over-designed buffer that's there to accommodate discrepancies in the enclosure, which is one of the major loads the mechanical system has to counteract. And so that is really, again, when we talk about sharpening the pencil and how we do our analysis and how we understand how it's going to perform, a great example is there's no standard for how to deal with spandrels. It doesn't exist. Everybody has their own way to deal with it. We have very rudimentary examples of how to, sure, I'm going to take the R value that's in behind an insulated spandrel, whether it's a shadow box or spandrel glazing or something like that, right? That is considerably overestimating the actual performance that's going to occur. And so we're catching up, we're building the tool set, we're validating the methodologies that we use, but it's a work in progress. And so we all sort of, every aspect of design really does need to look at it because, it'll be another couple of years before we have a real good standard that helps to guide designers in how you analyze glazing spandrels and how you accommodate for that performance in an energy model. So we really all need to be sort of pushing in that direction because the idea is we're trying to trim as much excess as possible, and so the systems have to work together very well and respond together very well over the full year and the full occupancy of a building.
So this kind of correlation between the facade design and the system design, I think the optimization between those two that we're kind of talking about right now and talking about the importance of moving forward certainly has an impact as well on utility bills potentially. So Ruth, I think how do you see kind of the role of facades and how you're viewing it for your development?
I think we also and gave residents, programmable thermostats with individual HVAC units in. That saves $275,000. So we're just one community, it's almost $500,000. And so we see that as one, it's great for the environment and just, keeping energy usage to a minimum as possible. It's too great socially for our residents that they're getting the benefit in seeing some financial benefit there, and then obviously prosperity piece for us and the economic more longer sustainable operating property that we can continue to keep as low as possible in terms of the affordability of rents.
And you've mentioned kind of we're merging now into the existing building realm here. So you mentioned kind of some of the thinking that you have on the early stages, especially from a systems perspective. But let's now talk a little bit about existing buildings and what we can do with them from a facade perspective and how we're starting to look at that, particularly in reference to the BEPS legislation. So Brad, you mind talking a little bit about your work there?
When we look at building facades in existing buildings, right, we can go in two different paths. There are historic buildings that have a lot of sensitivity to how we improve the performance, and there are good guidelines for that, whether it's National Park Service Preservation Plan 3 that describes how we do energy retrofits on historic properties, and we've got to be very sensitive to how we do that. But also on the rest of the building stock that's out there, there are opportunities to improve the performance of those buildings, and that's just really going to help to drive that. Benchmarking against the peers in the locality to say how can we do this? How can we make improvements? How can we make smart improvements? But it is a challenging proposition of an existing building. Unlike a new design where you're able to contextualize the building, understand what the exposures are, and maximize the benefit of the design, you're dealing with an existing building. In an existing site, you can make some modifications to it, but sometimes you're relatively limited. You want to be economical with how you approach it. And that sort of begs another question, which I'm interested in Roger's take on, is we can use the technology, leverage the technologies. We talk about a new design, the idea of having a passive design that's really responsive to its environment, but we can leverage the technologies in order to solve limitations of existing buildings and help us there, whether it's insulating mass masonry walls and providing an air barrier in those, whether it's retrofitting existing glazing. Right? And a project a little over 10 years ago was the first one that I'm aware of, where we studied retrofitting rolled steel historic windows. They were going to rip them all out, of course, being the landfill and all that embodied energy gone, right? And they're beautiful windows, rolled steel windows, retrofitting them with an interior glazing storm versus replacing them with a brand new thermally broken window. As it turns out, the retrofit window with an interior storm is actually better performing from an energy standpoint, better performing from an air infiltration standpoint, and a view factor standpoint than a brand new window. So we're able to find creative solutions to existing building problems. But the challenge is, how do you phase it in a way that works, right? You can't reduce the demand on the mechanical system, upgrade the mechanical system all at once, right? So how do you do that so that you can make improvements in your mechanical system, right? So it does become a very thoughtful and step-by-step process of how you make those improvements.
Roger, you want to speak at all to the envelope improvements and the phasing of mechanical improvements?
Yeah, I think the role of phasing becomes so surgical in nature sometimes. Because if we take an existing condition and the building is, let's say, 100 units of heating energy, and the size of the air source heat conflicts in that, or do we reduce demand first and then sort of half the size? And that's so critical, especially in existing context. We don't have a lot of these things sometimes to work with and environment and residential space and somewhere. And so trying to break down the project into bite sizes without losing efficiency and building at a time. That sweet spot requires so much collaboration within the contractor as early as possible. But the analysis, right, I think you're alluding to, requires so much more sophistication and early reviews. So before we might look at just one moment in time,
about constructability. Let's Andy, let's hear from you a little bit about some of the recent work that you've been doing, taking new DC schools that aren't in construction, but now existing buildings and trying to lead them towards net zero energy. And some of the approach that you've been taking to facade improvements and phasing in constructability to get them to the levels that you're looking.
I'm right now under construction in a school modernization. That is a modernization with 2 additions. The additions are the current design. It should work out very well there. But what we're striving to do is we're striving to have the end result equal to what we would achieve in construction. And I think when you analyze the existing facade, and you look at how to fill that, how not to trap moisture, how to work through those issues, I think you can build a wall that is that's equitable. And obviously in a renovation, the existing holes, the existing openings, the existing windows, all of those things play into it. That's typically where you lose the game. But the project that we're working on now, with the windows all out, we've improved the jams so that the steel between the building and the windows is going to be top notch. We also are looking really hard at all the other components and how the components integrate with the existing building, and working through that with our team and our commission agents. And I'm confident that we're going to have some really strong areas with lessons that we want.
So I love that we're ending this whole conversation, this whole day around moisture. Partially because I'm a nerd, but I think when we were meeting and talking, having conversations around how we're going to structure this panel, Roger came up with kind of great concluding statements for what we've been talking about here today. If you want to kind of jump in, if you remember what you said.
I don't even remember what I said. This is like last week. You can paraphrase for a moment.
We're talking about, it's really, we're celebrating all the building science, and it's kind of coming back full circle. We need to be more building scientists. If we're going to tackle this problem of how we're going to enhance our society, become more resilient, we need to play a critical role.
Definitely. Thank you for that proper reminder. We all are building scientists, regardless of our core background. I think we've seen that we have to have this technical empathy across different trades, and building science really rocks, and that's the key to our success.
I've been muted as a developer. I'm just going to say that it sounds like I'm going to have to hire a bunch of new building nerds to help me engineer the latest and greatest net zero buildings moving forward. So, because it's clear as mud to me.
Okay, well that ends our panel discussion. Thanks so much for joining us today.
Great, thank you all so much. That was an excellent way to end the conference today. And yeah, so just a quick reminder, AIA credits on your way out if you haven't signed up yet out at the registration desk. And yeah, thank you all so much for sticking around and for really engaging conversation on a very important topic in our home city. So really excited for all of that. So.
Thank you, John. So, as I mentioned in the morning, we've recorded today's event, so we'll share the YouTube video with you next week so you can catch up on anything you missed during the course of the day. Thank you to all our sponsors, and a round of applause for all of you for staying back and attending today's event. I hope you liked it. And also a round of appreciation for our 2 event hosts, Angel in the morning. He had to leave us during lunch. And then John, thank you so much for hosting this event. And I look forward to hosting you next time whenever we return to Washington, D.C. Thank you.